Okay, welcome to your first lesson on how to solve linear equations. So, what we're going to do here is we are going to solve a series of problems until you become acquainted with it, okay? So, for example, bugs over here. Nice. The first thing that we need to learn is about the additive inverse, okay? The additive inverse of any number is its opposite. For example, the additive inverse of -10 would be +10. Now, how do I know that? Well, when you add them both together, you get 0. 0 is the identity element of addition. Okay, got it? All right, so if I have +5, then the additive inverse is -5. And when you add them together, you get 0. That's how it comes when you do the opposite, you cross them out. All right then. Now the additive inverse of -1/2 would be +1/2. See that? And this is the proof. This is how you know that you got the additive inverse. All right then. Now the other thing I wanted to talk about was the multiplicative inverse. Okay. Multiplicative inverse. Multiplicative inverse. Okay, the multiplicative inverse of any number is nothing more than its reciprocal. The reciprocal of 3/2 is 2/3. Now we're talking about multiplication. When you multiply this number, you get 6/6, which is 1 whole. Okay, 1 is the identity element of multiplication. Very good. All right. If I want the multiplicative inverse of 1/2, then I use the reciprocal. So that will be 2/1. Notice something. The difference between this and the additive inverse here is that you do not change the sign. For example, what is the multiplicative inverse of -3/2? Well, that will be -2/3. As simple as that. Good. All right then. So moving on, the next thing that we need to know is how to find the lowest common denominator. Okay? The lowest common denominator. For example, if you have 2/3 plus, 1/2 plus, 1/5. Okay? And you're supposed to add this. Well, the first thing that we do is we find the lowest common denominator, or also called the minimum common multiple. Let's call it LCD, lowest common denominator. So what we do, okay, this is my method. It's called the method down to 1. So you take all the denominators, the bottom part of the fraction, right? And you start, you know what? Let's add 1/4 over here just in case. All right, so what you're going to do is the following. You take all the denominators, 3, 2, 5, and 4, okay? And now you are going to divide by the lowest number possible except 1. You're going to start dividing at 2. So first, look at these numbers and say, okay, can I divide by any of these numbers by 2? And in effect, you can. This one and this one. So I'm going to divide by 2. 5 does not divide evenly with 2, so it stays at 5. 2 divided by 2 is 1. You see that? Nice. 3 doesn't divide by 2, so it stays at 3. 4 divided by 2 is 2. Okay. Now, I repeat the process until all the numbers are down to 1. So what is the lowest number possible that I can divide by? Well, here I can see that I have an even number. Therefore, I can also, again, divide by 2. Remember, 5 doesn't go into 2, so it stays at 5. This is already down to 1. 3 does not divide into 2, so it stays at 3. Okay? 2 divided by 2 is 1. That's it. Okay. Now, again, what is the lowest number possible? Well, I cannot divide by 2 anymore. So, but I can divide by 3. Okay, can I divide by 3? Yes. 5 doesn't go into 3 evenly, so it stays at 5. 3 divided by 3 is 1. Right? Then, again, and this is down to 1. And guess what? Now your lowest common denominator will be the multiplication of these numbers right here. 2 times 2 is 4, times 3 is 12, times 5 is 60. Okay? And that is your lowest common denominator. Okay? Now, the next thing that I'm going to show you is a different way of finding the lowest common denominator with the same numbers. Okay? This is called finding a common number among the multiples. So you take your denominators, 3, 2, 5, and 4. If you prefer this method, by all means, you're more than welcome to use it. Me, on the other hand, I rather the method called down to 1 because it's hard. I mean hard, easier. Sorry, my bad. I gave it away. So here, to find the common denominator, you're gonna actually use the times tables, the multiplication tables. So for example, 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15, 18, 21, 24, and so on and so forth. 2 times 2 is 4, times 3 is 6, times 4 is 8, times 5 is 10, 12, 14, 16, and so on and so forth. 5, 10, 15, 20, 25, 30, 35, 40, and so on and so forth. 4, 8, 12, 16, 20, times 6 is 24, 28, 32, and so on and so forth. Well, you will continue. Okay, I run out of space, and that's why I don't like this method. You're gonna continue, and there will be a point in time where all the numbers are going to have 60 as the common multiple. And now it only makes sense, because is there a number that multiplied by 3 gives you 60? Yes. Is there a number that multiplied by 2 gives you 60? Yes. Is there a number that multiplied by 5 is 60? Yes. Is there a number that multiplied by 4 is 60? Yes. So you're gonna go on forever until you get 60. Guess what? It takes a lot of space, and you don't want that. All right. So that is the second method. You still get the 60, but it's kind of like longer. It works with small numbers. It doesn't work with big numbers. The next thing that we're gonna do is we're gonna start solving equations right away. Okay, I just reviewed with you additive inverse, multiplicative inverse, and finding lowest common denominator. Okay, so welcome to this lesson. This is a very extensive lesson. We are going to solve linear equations, and I am going to try to do my best to cover all aspects of solving linear equations. I have additional videos, 2 additional videos. Basically, the equations in there are kind of like a little more sophisticated. We're talking about linear equations. So let's start solving with the basics, okay? First of all, what is a linear equation? Well, a linear equation is an equation of exponent 1, meaning what? That you could have any variable. You could have n, x, b, the whole alphabet. But the exponent is always going to be a 1. Okay, the leading exponent is going to be 1. The degree of the equation is going to be 1. Okay, that's what we call the exponents. Alright, for example, when you were in like 3rd grade or something, they gave you a problem that would say box plus 3 equals 5. This is what we call an open sentence. We need to figure out what the value in the box is in order for us to have a result of 5. So what will be the value that we will put in the box in order to make this true? Well, I would put what? Box plus 3 equals 5. So I would put a 2 in the box, and I have 2 plus 3 equals 5. Now, to solve equations now, we don't have a box. This is high school, so now it gets a little trickier. Now we're gonna use variables. Variables are letters that represent an unknown value. So for example, now they might ask you something like x plus 3 equals 5. So the box is being replaced now with a variable. Yeah, child's play. So we know that x is going to be 2. X is going to be the value, is going to take on the value of 2. Because if we substitute 2 over here, 2 plus 3 is 5. Okay. But now in the algebra class, it's not so like, oh, I'm going to just use my common sense and use the value and figure out, okay, y plus 3 is 5, which is basically the common sense, what we see in life. No, to solve the equations, now you have to think backwards. In other words, you have to undo what has been done, always to the variable. For example, please pay attention. The value, okay, of x is being increased by 3. Okay? So because the value is being increased by 3, now we have to use the opposite operation or the inverse operation. We are going to subtract 3. Why? Because the idea behind solving an equation is to leave the variable by itself. Okay? But anyways, what happens if I subtract 3? Well, this is an equation. An equation has to be balanced. If you are going to take away 3 from this side, you have to take away 3 from the other side, right? So then, I also take away 3 from this side. And of course, 3 minus 3 is 0. So it only leaves you with the x. 5 minus 3 is 2. So the same value. Oh, come on, Bex. But the thing is that, like, why am I going to think so hard if I know that 2 plus 3 is 5? Because, as it is my experience, you don't like fractions. You don't. So then, you're going to be in trouble if you don't follow certain rules that we're going to discuss in later episodes. Or later on. I don't know. Depends. Alright. So, when you have, this is what we call a one-step equation. All you did was to utilize the additive inverse of the number. You see? Let me give you another example. Whenever you have, okay, x minus 4 equals 12. So I know. Let's use our common sense first, and then we'll use the algebra. So what, we covered the unknown, the box, and we say, what value minus 4 is 12? Well, the value is 16. 16 minus 4 is 12. So we know that x is going to be 16. We know that x is going to be 16. But now, algebraically, we have to undo whatever has been done. Well, the value is being subtracted by the number 4. So I must, and I am going to start using academic vocabulary. I'm going to start using the proper name for what we do. We have to undo this subtraction of 4. So we are going to add 4. Think of it this way. A number minus 4, okay? A number decreased by 4 equals 12. What is that number? Wait, a number. And right now we know it's 16 because it's common sense, it's right, it's a plain sight, you could see it. But if not, then you would say, wait, hold on a second. I took away 4 and I got 12. If it was a bigger number, you would have to think like this. 12 plus 4 is 16. So 16 minus 4 is 12. 16. So you see what I'm saying? Okay, don't panic. This is the beginning. So we have a subtraction by 4. So we're going to add 4. We're going to undo the subtraction. Okay? But what you do to one side, you always do to the other. See that? Plus 4, and now x, this cancels out because 4 minus 4 is 0. Or negative 4 plus 4 is 0. Or look at them, they're opposites, they cancel each other. So that's 0. So I just bring down the x. And then 12 plus 4 is 16. Right? Okay, cool then. So that takes care of this one. So every time you have something like an addition or subtraction, it's just a one-step thing. Like for example, I don't know, let's see if I have something like this. And let me change the color because I want to use a different color. Let's say I have 9x equaling 72. One-step equation. How do I read this? You read it as 9 times x, 9 times a number, equals 72. So 9 times what is 72? Well, we definitely know that 9 times 8 is 72. We know that 9 times 8 is 72. So x has to be 8. Oh yeah, I'm good at math and all that. Sure. Remember, this is the basics. Now, right now, we are going to look at it in this form. But later on, we have to use the proper names and the proper operation. What do you want? Oh my God. Okay, fine. Look. Here. There you go. Boom, boom, boom. Go. Goodbye. All right. So 9 is multiplying the x. So how do I undo this multiplication by 9? Look, I'm going to divide by 9. I divide by 9. So what's going to happen? 9 divided by 9 is 1. 1 what? 1x. 1x. So you see, there is no need to put the 1. So 1x. And then 72 divided by 9 is 8. You see, you have to undo what is being done. All right. So far, how many we have? 1, 2, 3. Okay, I want to do 100 of this. So let's see now. Kobe. No, Kobe. Oh my God. No. Vaya para allá. Vaya para allá. Vaya, goodbye. All right. So let's say we have another one. So what else do we have here? All right, cool. Let's say I have x divided by 9, okay, equals 9. X divided by 9 equals 9. And please, I mean, if you want to number them, I don't know, you're going to number 1, number 2, number 3, you want to call this number 4. It's okay. So, what number divided by 9 is 9? Right. What number divided by 9 is 9? The number is 81. Look. X is going to equal 81. Because 81 divided by 9 is 9. But now the algebraic way of doing this is the following. So I have a division by 9. So I have to undo that division. So how do I undo a division? With multiplication. How do I undo a subtraction? With addition. And addition with subtraction. So, I'm gonna die. No, I'm gonna die. All right. So what I'm going to do is I'm gonna open parentheses on the whole equation. And I am going to put a 9 here and I'm gonna put a 9 here. Remember, a division by 9 is undone with a multiplication by 9. A division by 5 with a multiplication by 5. A multiplication by 5 with a division by 5. You see, you have to use the same number, okay? Later on, it's not going to be that easy. Later on, we have to call it by the proper name, so don't worry about it. All right, so this is what happens. 9 times x is 9x, right? And 9x divided by 9 is 1x. Or if you want to say something like, when you multiply and divide by the same number, they cancel out, but they don't become 0. Remember, 9 divided by 9 is 1, so 1x. And then 9 times 9 is 81. And that's how you solve one-step equations. All right. Now, let's have another one. x over 7 equals 12. Okay? So, I mean, not, I made a mistake. It's not x over 7. Sorry, my bad. Is x plus 7 equals 12. Okay, that's what I have. Sorry. So now what's happening to the x? It's being added by 7. It's been increased by 7. And let's start using vocabulary. This is an addition by 7. So what do I have to do? A subtraction by 7. Or use the additive inverse property of equality. Use the opposite of the number. See? So it all is the same, but you call it by the proper name. So now what you do to one side, remember, what you do to one side, you gotta do to the other. Cross that. So 7 minus 7 is 0. So that only leaves you with the x. I hope you can see this. Let me see. Can you see it? Yeah, you can see it. And this cancels out. 12 minus 7 is 5. See that? Let me see if you can see it. Barely. Okay. So this is what we call one-step equation. Kobe, I am going to go ahead. Okay. Oh, don't bring it over here. Okay. So let's continue with this one-step equations. They're the easiest ones to do, but you have to be careful. All right. So let's have something like this. 35. Okay. What was this? Number 5. Okay. 35 divided by x is 5. 35 divided by x is 5. Okay, I have no idea what that is. So 35 divided by a number is 5. Of course, I know the number is 7 because 35 divided by 7 is 5. But algebraically, let's see what's going on. You never want to have variables as the denominator. You don't want to have the x in the bottom. Those are called fractional or rational equations. So how can I bring this x to the top? First, always think about eliminating the denominators. How do I eliminate this denominator? Well, oh my God, I have to undo the operation. X is dividing, so what I'm gonna do is I'm gonna multiply the whole thing by x and watch what happens. So I multiply by x. So what do I have here? X times 35 becomes 35x. No, oh yeah, over x, right? X times 35 is 35x, and then over x. If you want to put a 1 under the x, that's fine. All right, and equals 5x, because 5 times x is 5x. Now, look at this. When you multiply and divide by the same number, they cancel out. Okay? So how am I going to do this? Do I have a red marker? Yes, I do. No, don't fall. Okay. So they cancel out. X divided by x is 1. So 35 times 1 is 35. Really? Oh well, I'm stuck to red, so I'm gonna do red. 35 equaling to 5x. Oh, okay. And now, remember, the idea is to leave the variable by itself. So 5 is multiplying x, so I'm just gonna divide by 5. Okay? And x is 7. Cool? Okay. Now, this was number, no, this is number 5. Okay. Let's do another one. Alright, number 6. X divided by 8. X divided by 8 is 3 or equals 3. How am I going to solve this? This time I am not going to do what you think. Or no, actually, I'm going to do what you think. So x is being divided by 8. I need to undo that denominator. I don't want denominators. So I'm going to multiply by the common denominator. Or I'm going to undo this division by 8 with a multiplication of 8. Okay? So 8 times x is 8x. Divided by 8 is just x. 3 times 8 is 24. And at the end, x is 24. Alright, so now let me show you something very interesting and something that you need to keep in mind all the time. I haven't given you the rules, but you gotta keep this in mind all the time. This is gonna be like the longest video I ever do. So I have x over 8 equaling 3. So what is happening here? X is being divided by 8. So this is one of the rules. Whenever you have this division by 8, it is actually a multiplication. I'm going to show you. This is a 1x. I can rewrite this, and correct me if I'm wrong, I can rewrite this as 1 over 8 times x equaling the number 3. Okay? It's hard, but you have to understand it this way. So when we have more complex equations, you'll be able to do it. You could actually call your parents to see if they actually understand. And I use the word actually twice. Alright, so now, this is a multiplication of 1/8. There is a reason why I taught you before about the additive inverse and the multiplicative inverse or multiplicative inverse or reciprocal, whatever you want to call it, is the same thing. When I am going to undo this multiplication of 1/8. How do you undo a multiplication of a fraction? You use the multiplicative inverse. The idea behind the idea behind dividing by 8, multiplying by 8 and all that, the idea is that before that you use the multiplicative inverse. So watch this. I'm sorry I'm going to go beyond this, but you're going to multiply by you're going to multiply by 8 over 1. You're going to multiply by 8 over 1. For what? What is that going to do? If you multiply by 8 over 1, this is what's going to happen. This is the reciprocal of 1 over 8. You know that. 1 over 8, 8 over 1. Now watch what happens. So 8 times 1 is 8 over 8, because 1 times 8 is 8, x equaling 24 over 1, because 3 times 8 is 24. So we have 24 over 1. Now what happens? 8 over 8 is 1x. And of course 24 over 1 is just 24. So we have the same result. I'm not saying that you need to use this method all the time. I'm saying that you need to understand this method all the time. So let's see what's going on. We're gonna do a bunch of this until you understand it. You already understand that multiplication is undone with division, division with multiplication, addition with subtraction, and all that. For example, let's try this. What was this? Oh my god, number 7, I think. Alright, 9x equaling 54. Alright, so I'm gonna do it in 2 different ways. So here I have 9x equaling 54. So the way we did at the beginning is, okay, x is being multiplied by 9. 9 times what is 54? we know that 9 times 6 is 54. So, let's see now. What do we have? Oh, did I just lose it or something? But wait, hold on. I think I lost it. Where is it? 54, 54, 54, 54, 54, 54, 54, 54, 54, 54. Ah, found it. Thank you. Okay. So, 9 times 6 is 54, but, well, we already know that. So algebraically, the easy way would be, all right, so 9 is multiplying x, so I know I have to divide by 9. Divide by 9. This cancels out. X is 6. So that's it. Yeah, no, that was easy, right? But now let's do it the hardcore way, okay? Because this is the correct way. Once you do it like that, forget it. There won't be any equations that you cannot solve.
54 divided by 9.
So let's see now. We have here, I'm not gonna divide by 9. The reason I divided by 9 is because of a previous step. And that's exactly what we're going to make sure you understand. 9 is multiplying x. When you have a multiplication, just the multiplication itself, use the reciprocal of that number. Use the multiplicative of that number. Use the multiplicative inverse, multiplicative inverse. What is it? Well, I'm going to take the 9x, okay? I'm going to take the 54, and I'm going to multiply. Remember, I'm going to multiply by the reciprocal. What is the reciprocal of 9? I don't know. Hello? This is a rational number that can be turned into 9 over 1. So what is the reciprocal of 9 over 1? Bex, you got it. The reciprocal of 9 over 1 is 1 over 9. And what I do to one side, I do to the other. Yeah, but just divided by 9 is easy. Son, sorry, you know how it goes. So now, if it's easier for you to put 9 over 1, you could do it. I am not going to do it. I'm going to multiply straight through. So 1 times 9x is, oh wait, let's go back to red. 1 times 9x is 9x, because any number times the identity element of multiplication is itself. So 1 times 9x is 9x over 9 times 1 is 9. That equals, if you want to put this 54 over 1, be my guest, you can do it. So 54 times 1 is 54. And then 9 times 1 over here, invisible 1, it's 9. Bex, you're going back to what we had here. Why are we doing math work? What for? Like, come on, what's going on? You have to understand where this came from. This came from using the multiplicative inverse property of equality. So, now, 9 divided by 9 is 1x. 54 divided by 9 is 6. Okay? So from now on, we're going to be using the multiplicative inverse so you can understand. We're not just going to divide by the number. Later on, when you become proficient, then you could do that. Right now, we cannot. All right, let's go to another simple equation. All right, let's say, okay, 4x equals 8. 4x equals 8. So 4 is multiplying the x, so I am going, okay, so 4 is multiplying the x, so I am going to undo this multiplication using the multiplicative inverse. So I'm going to multiply, oh, this is 4 over what? Exactly, 4 over 1. So I'm going to multiply by 1 over 4 on both sides. What you do to one side, you do to the other. Listen, that's the way it goes. So 1 times 4x, and by the way, when you multiply and divide by the same number, they cancel out, right? So, cancel out. What you have left? 1x. 8 times 1 is 8, right? 8 times 1 is 8, divided by 4. 8 times 1 is 8 over 4. What is 8 over 4? 2. See? Now I'm going a little faster. Okay, number 9. And so far we have only done equations that involve only one operation. Alright, 7x equals 21. Okay, 7 is multiplying the x. By now you should know that, okay, yeah, let's undo the multiplication with a division by 7, divide both sides by 7, x is 3. Yes, I get it. But for the purposes being, we still need to use the multiplicative inverse until you become acquainted. So, 7 is multiplying x, so I'm going to use the multiplicative inverse of 7. What is the reciprocal of 7? Well, what is the reciprocal of 7 over 1? Oh, 1 over 7! So we're going to multiply by 1 over 7 on both sides of the equation, right? So let's see now. 1 times 7x is 7x. Divided by 7 is just x. Or you could say, when you multiply and divide, because this is a division, look, 1 divided by 7. When you multiply and divide by the same number, they cancel out, leaving you with 1x. 21 times 1 is 21 over 7. In other words, 21 divided by 7 is 3. Okay? Alright. It's time to do the next equation. So I'm going to change the the marker. I'm going to go to black again. Alright. So I have where is that thingy? Okay, 13 minus x equals 1. So number 10. 13 minus x equals 1. A number minus something, 13 minus something is 1. We know that x is going to be 12 because 13 minus 12 is 1. But that's not what I need you to do. Yes, that was the common sense, and I am sorry that in high school they are taking your guessing, your critical thinking into like something that is mechanical. But the mechanical way of solving equations, like the algebraic way, is going to help you solve more complex, more difficult equations, where you will have to think about what to do instead of what number fits into x. But don't worry, I'm gonna guide you throughout the way. So this is funny right here. 13 minus x. So I am going to undo what is being done to the x. Oh, subtraction is happening. No, subtraction is not happening. Addition is happening. This is a plus. Addition. The sign to the left of the number is what's happening to the x. Get it? The x is just a negative. But this doesn't mean that 13 is being subtracted from x. No. Let me rewrite this. Let me put the negative x first. And let me put the 13 later. Second. Okay. So now what operation was happening? Yes, addition happened all the way. Okay. So let's get rid of this 13. We know how to do it. We just use the inverse operation. Okay? So I'm going to use the additive inverse of 13. What is the additive inverse of 13? Negative 13. Correct? So now negative x equals, remember, additive inverses cancel each other. So 13 minus 13, that's it. It's 0. So bring down the negative x. Don't forget the sign. You bring it down the negative x. 1 minus 13 is negative 12. So your answer is negative 12. No, son. How? Okay. Secret, and learn it right now. You can never, ever, ever, of all the evers, have a negative variable as your answer. So, how do I fix that? There is two ways of fixing this. Okay? So I'm going to show you. You will use the change of signs property of multiplication. In other words, you're going to change the signs here. The x is going to become positive. But then when you change the sign of one side, you have to change the sign on the other side. But how is that possible? How can I just change the sign? Well, think of a number that can serve as a change of signs without altering the result. Well, that number, my friends, is, let me introduce you to the -1 property of multiplication. Multiply by -1. When you multiply by -1, look, 1 times x is still x. Negative times negative is positive. Woo! Negative times negative is positive, and 12 times 1 is 12. So this is your final answer. That is called the -1 property of multiplication. Okay? Let's continue with this. Okay, so let us go on to two-step equations. Ooh, I'm nice. All right, two-step equations. Oh my God, why is the dog in my... If I move this chair, he's gonna start crying like crazy.
It's been there for years.
Well, you need to move it. All right. So, let's see. Now I have the following. What is this number? Oh my God, I forgot the number. What was the last number? Yo, I'm a mess. I'm a young. Number 8, 9, 10. Okay, number 10. So we're gonna do number 11. Okay, is he moving? Yeah, thank you. Oh, okay. Wow.
Oh, so that's me.
Yes, whatever. Okay, number 11. So 16, wow, ugly 6. 16 equals 7 plus x over 7. So you gotta copy this, okay? All right. So how am I gonna tackle this? Now is the time where we're going to start showing proof of how to do this. First, I'm gonna draw a line right here. I don't know how many things I'm gonna use, how much space. So let's analyze what is going on here. Let me expand. Let me elaborate on that. So here I have a division of 7, and I have an addition of 7. Addition, not this addition, but this addition, okay? So I need to undo all that. So let me do it the way that I was teaching before, not the complicated one, the easy one, okay? Because we have room for that. So what I'm going to do is the following. Remember, you have to undo the operations that have been done. And remember, if you believe in pandas, well, solving a linear equation is the opposite of pandas. For example, in pandas, parentheses, exponents, multiplication, division, addition, subtraction. No, that's it. Well, so let me see. Actually, you know what? Let me write pandas. Pandas. Okay, so in pandas, when you're gonna solve an equation, you're gonna start. Let me see what it spells. You're gonna do SATMAD. Ha! SATMAD. SATMAD. In other words, you are going to work backwards. So if multiplication or division is the last thing that happened on the equation, well, that is the first thing you're gonna start undoing. It's like this. I'm building ta 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 ta. Now I need to unbuild or destroy or whatever. But we're not just gonna go like that, no. Then we have to start from the last place. Okay? We have to start taking out things from the last thing that we did. That's the first thing we remove. Right? That's it. That's what I'm gonna say. I'm not gonna go into a back line where the first one, no. So I am going to first undo division of 7. And how do I undo division of 7? By multiplying by 7. Okay, cool then. So I'm going to multiply the whole thing by 7. Cool. Alright. Remember, this could be 7/1 all the time. So, I need a calculator for this because I could be a math teacher, but I don't see numbers in my head. So let's see now. 7 times 16 is 112. Okay. So I'm going to write here 112. Now equals, because that's what the equal sign was. Remember, you're multiplying everything we're multiplying sides, not just items. Sides. So the whole side gets multiplied by that, and this whole side gets multiplied by that. So then it's like using the distributive property. So 7 times 7 is 49. I hope you remember this. And then 7 times x over 7 is gonna be, well, I'm gonna actually write the whole thing. 7x over 7. Smells good, like food, steak, oil. Okay. Now what happens here? Remember, you were multiplying by 7 and dividing by 7? That's why they cancel out. So let's bring down what we have left. X, the plus sign, the 49, and then the 112. Okay. What's happening now? Well, x is being added, increased by 49. Okay? Not this one. This invisible positive. That's the one. I could write this as x plus 49 if I wanted to. So anyways. So I am going to undo what? Addition of 49. Okay? I'm going to undo it with subtraction of 49. Jesus Christ. Yeah, I know, I write ugly, but you'll understand. Alright, so I'm going to subtract 49 from both sides. Because what you do to one side, you got to do to the other. Ha 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 ha. Okay, so what do we have? We have that 112 minus 49 is, I think is 63. Yes. 49 minus 49, leaving you with x. See that? It gets a little more complicated, right? Yeah, I know. Okie dokie. So now, what else? Fine, let us do the same problem, but using the real academic vocabulary, okay? So still number 11, we have 16 equaling 7 plus x over 7. So I have to rewrite this as 16, and I'm gonna use a different ink. I have to write this as 16, okay, equaling to 7 plus, watch this, this is a 1 over here, 1 over 7 See, I separate the number part. 1 over 7 times x. Okay, cool. Now for the proof, for the explanation. Well, the fact is the following. Whenever you have an equation that has two operations like this one, division and addition right here, there's only two properties that you will always use. Okay, so you see now we're gonna get into the properties, into the rules. There are golden rules. Yeah. Okay. First, you will use, okay, and this is gonna be funny, cause I could have done the following. Okay, so now let's see what's going on. Okay, now let's see what's going on. First, you use the additive inverse of a number. Whenever you have a two-step equation. Yes, we did this using our common sense, using all that. It's funny how I undid division and all that. This is when you want to break your head and think about how to do it. This is more like mechanical. It's always going to happen like that. Okay? So add additive inverse. You're going to use the additive inverse. Well, the additive inverse is only used on numbers that are adding or subtracting. Right? So I'm going to use the additive inverse of 7. Because definitely this 7 is just dividing. This is the 7 that is adding. So what is the additive inverse of 7? Wait, no, not here. Here. I'm going to use the additive inverse of 7. Remember, what you do to one side, you do to the other. Don't ever put or subtract a number and then the same number on the same side. No, we are doing sides and then the other side. I have people going like -7 here, -7 here, and then all of a sudden the whole thing is wrong. No. So this cancels out. So what do I bring down? 1 over 7x, correct? What is 16 minus 7? Thank you, 9. Okay. And now, this number is multiplying the x. This fraction is multiplying the x. I know what I said, times 1 divided by 7, yes. But the fraction is multiplying the x. Alright. So, after you use your additive inverse, the second property that you're going to be used is called the multiplicative inverse. Multiplicative inverse. Of what? Of the number that is multiplying the variable. So I'm going to use the multiplicative inverse of 1 over 7. And what is the multiplicative inverse of 1 over 7? 7 over 1, ugly 7. 7 over 1, ugly 7. Now, remember, as I said before, when you have a number and it's reciprocal, or a number and the multiplicative inverse, they will cancel each other. You're multiplying by 7 and divided by 7, you get 1. Multiplying by 1 and divided by 1, you get 1. So 1 what? 1x. Now here we get 9 times 7 is 63. I am not gonna bother to put over 1 because that's like corny, right? Like you don't want to put it over 1. We already understand it's a rational number and blah blah blah. Okay? Cool then. We are approaching the fantastic golden rules. So let's see now, what do we have? Oh, here we go. Oh, this was 11. 11. Wow. So right now, and so far, all we're doing is solving equations that have solutions. Don't worry, I'll guide you through the whole thing. All right, let me have another equation that we have here. Okay, 12x plus 120 equals negative 48. So this is equation number 12, and we have 12x plus 120 equals negative 48. I hope you can see it. me see. Can I zoom in? Nah, I cannot zoom in. Actually, I can, but then my face is gonna be too big. Nah, I'm good. I'm Gucci like that. All right. So let's see what's going on here. How many operations are involved? Well, I see a multiplication, okay, by x, and I also see an addition. You see, to the left of the number, an addition of 120. So all I have to do is undo that. But remember, we're using academic vocabulary, and basically the first step that I'm gonna use when we have two operations like multiplication and addition, then we're gonna backtrack, we're gonna reverse engineer, and I told you what are the properties used. First, we're gonna use the additive inverse. We're gonna get rid of, according to pandas, multiplication goes first and addition goes last. Well, according to, what was that, naptan, whatever pandas backwards is, we're going to undo the addition first, because it's backwards. So we're going to use the additive inverse of what? Of 120. So how do I undo this 120? With negative 120. And what you do to one side, you do to the other. See that? Okay, neater, right? Okay, and now bring down the 12x. This cancels out. Negative 48 and negative 120 is what? Negative 168. And now, the second step is to undo the multiplication. How do I undo it? I know, don't say divide by 12 on both sides. I understand. We could divide by 12 on both sides, it cancels out and give us the number. But again, I need you to understand the multiplicative inverse step. Oh my God. Okay. So, let's see. I'm going to use the multiplicative inverse. Of what? Of 12. What is the multiplicative inverse of 12? Well, this is 12 over 1. So then the multiplicative inverse is going to be 1 over 12. So far so good? Let me see if I can make this a little bigger, but I don't want to because then I'm going to die. Let me see now. Okay. Yeah, that's much bigger as I'm going to make it. Alright. So remember, what you do to one side, you got to do to the other. So you also multiply by 1 over 12 here. Alright. So what happens here? What is the idea behind the multiplicative inverse? The idea behind the multiplicative inverse is to get rid of what's bothering the x. Look, when you multiply a number by its reciprocal, they cancel out and leaving you with 1. Remember, look, 12 times 1 is 12. 12 times 1 is 12. 12 over 12 is 1. 1 what? Not bananas, but x. And now what is negative 168 divided by 1 over 12? Well, negative 168 times 1 is negative 168, because anything times 1 is itself. And then when you divide it by 12, which one is this one? Okay, I'm done because I don't remember. I think it's okay, so there's the 14. Okay, so this is well, negative times positive is negative, right? And we have negative 14. If you did it before I did, then thank you for giving me the answer. If not, lost points. Alright, so that's it. Two-step equations. Additive inverse and multiplicative inverse. Okay? Later on, you won't have to, if you don't need to, use the multiplicative inverse. You can just like, okay? So, let us do another one. Okay, so we're gonna go with 13. 13, we have 2 equals x over 4 minus 1. 2 steps. Look, we have division, which in reality is not really division, it's multiplication. And I'm gonna show you why. This can be rewritten as 2 equals, what is 1x over 4? 1 over 4 times x. Hopefully you remember. And then minus 1. Okay? Now that I have rewritten this, let me do the proof. Remember, look, I don't have to look at that. I already saw it. I saw the multiplication and the subtraction. So the first step is to use the additive inverse, and the second step is going to be to use the multiplicative inverse. As simple as that. Make sure you use it on the right, correct number. Don't be trying to use the additive inverse on a multiplication. No. No. So additive inverse of -1. Well, what is the additive inverse of -1? Nice. So +1 plus 1. Opposites cancel out, leaving you with 1 over 4x. 2 plus 1, 3. Okay, and now we're going to use the multiplicative inverse. What is the multiplicative inverse of 1/4? 4 over 1. I don't write over 1 because, so 4 over 1, but I'm still saying it. So that's it. When you multiply and divide by the same number, what happens? They cancel out, leaving you with 1x. Okay? Good? Alright then. Whew. Let's see now. Oh, I hate this. I really do, but we gotta do it. Okay. So we have, the only problem here is that we have big numbers, but I'm gonna try to keep it as simple as possible. I lost track of the number. Should I keep I don't, what number was this? Uh, 13, okay. So, we did one-step equations, two-step equations. Now we're gonna do multi-step equations, and here I might have to start giving you the golden rules to solve linear equations. Okay, so we have, what was the number again? 13. Okay, so this is 14. 14. Can you see that 14? Yeah, you can see the 14. Okay, so we have -18 plus 12x equals 14x plus 44. So here now we have an issue. It's a big equation. And I am going to zoom in just a little bit because we need to, otherwise, okay, there you go. Okay, wasting time. I know we're wasting time. Would you instead, or would you better? Oh, okay, here we go. Alright, so hopefully it's more visible. And now, my head is the only thing you see there. Now, let's see what we have. When we have two-step equations, we only use the additive inverse and the multiplicative inverse. Those are the last two rules that we use when solving linear equations. But here we have more, so I'm gonna have to actually, let's see what's going on. Alright, look, what operations do we have? We have multiplication. Just because you see this plus here doesn't mean that it's adding. No, this just says that this 12 is positive. 12 is actually multiplying the x. And then there is a subtraction of 18. On this other side, we have a multiplication of 14, okay, by the x, and we have an addition of 44. But then, so what's the problem here? No, there is no issue. But before we can use the additive inverse and the multiplicative inverse, we have to make sure that we only have variables on one side. And here we have variables on both sides. So that's the first thing that we're going to address. Okay? Now, not really. Sorry. Before checking if we have variables on both sides, we have to check if we have like terms. Like terms on each side of the equation. Okay? Don't be saying, oh, 12 and 14 are like terms, so we need to combine. No, you can't combine them. This is one continent and this is another continent. They're separated by the equal sign. So then you cannot do it. So we cannot combine like terms? No. So that's why we are going to look at variables on both sides. So what to do if I have like variables on both sides? Get rid of them by using the additive inverse. Wait, but isn't the additive inverse what I need to? Yes. But whenever you have variables on both sides, use the additive inverse. Okay? And usually use the additive inverse on the smaller one. So I should use the additive inverse here. Okay? Now, the rule is going to be VBS. What in the world does that mean? Variables on both sides. Do I have? Yes. So what do? Get rid of them by adding or subtracting it, right? So let me get rid of this. Let me get rid of this 12, okay, by subtracting 12x on both sides. Okay? Watch what's going to happen. So, woo! Alright, bring down the 18 because I really didn't do anything to it. This 12x got wrecked. Ha! It got cancelled. So, boom. Then we had the equal sign. Then we have 14x minus 12x. If you have 14 x's and you take away 12 x's, how many x's do you have? You have 2 x's left. And now I didn't do anything to the 44, so plus 44. Okay? So now, wait, let me just rewrite this. Negative 18, because I wrote it, okay. I wrote it too small over here because I brought it down. Anyway, let me put it over here. Now, this is 0, remember that. Alright, so I have negative 18 equals to 2x plus 44. Now we go back to having the variable on one side and to have two operations. So guess what are the two last operations that we use? We use the additive inverse and we use the multiplicative inverse. The additive inverse of what? The number that is adding or subtracting. So plus 44, let's use minus 44. Minus 44. Okay? And now we do the math. This cancels out. As I progress, I'm going to start doing this faster and faster and faster. So now we have, okay, what is negative 18 minus 44? Or negative 18 plus negative 44? It is the same thing. In other words, negative 18 is on the left of the 0. And this is a command to go 44 to the left. So, So in other words, you add them. So let's see. Or you could just use the... Okay, so let's see. So negative 18 minus 44 is negative 62. And that was for the additive inverse, right? Now we're going to use the multiplicative inverse of something. Of something. What is that something? Whatever is multiplying the variable. So what is the multiplicative inverse of 2? Well, think of it. Every time you want to use the multiplicative inverse, turn the number into a fraction. So this is 2 over 1 actually. So then the multiplicative inverse should be 1 over 2. I know what you're thinking. Becker, this is 2 times x equals negative 62. Why don't you just divide by 2 on both sides and that's it? I like, stop with that multiplicative inverse thing. I'm sorry, but that's the way we're going to have to do it. And I'm still going to remind you, yeah, that you could just divide by 2 on both sides, but Alright, so what's the idea behind the multiplicative inverse? The idea is that when a number is multiplied by its reciprocal, it divides, okay, or multiplies, and the answer is 1, the identity element of multiplication. So then now we have x equals, well, 62 divided by 62 times 1 is 62 divided by 2. What is 62 divided by 2? Well, that's 31. Now negative times positive is negative, so this is negative 31. See that? Cool, right? All right, then let's do another one. Let's see. 15. Woo! Which one? Okay, this one is good. Negative x minus 32 equal 19 minus 4x. Okay? Let me see if I can make this a little lower now because we are going to okay, here we go. Yeah, I think that's good enough. All right. So how am I going to solve this? How do I do this? Well, same concept. Think about it. Before you think about additive inverse and multiplicative inverse, which is the last two rules, think about like terms and variables on both sides. Do I have like terms on this side right here? Negative x and negative 32 are not like terms. If they were like terms, this will have an x, right? What about on this side? Remember, the equal sign is what divides the sides. So, do I have like terms here? I don't see like terms. Okay, so what about variables on both sides? Yes. So how do I do this? Well, remember what I said. We have VBS, variables on both sides. What does that mean? That means that I need to get rid of one of them by adding the opposite, by using the additive inverse basically. And I said get rid of the lesser one usually. Which one is less? Negative 1x or negative 4x? Which one is smaller? Right, exactly. Negative 4x is smaller, so I'm going to use the additive inverse of negative 4x. And I just wrote 5, right? Yeah, okay. 4, 4, 4, 4. Oops. Alright, so plus 4x. What do I have? I have negative 1 plus 4 is 3. Bananas? No, x. Minus 32, okay, equals 19. And here, negative 4x, positive 4x, what happened to them? They became the identity element of addition, which is what? 0. Do not confuse the identity element of addition with the one of multiplication. Multiplication is 1, addition is 0, 0, 0, 0, 0. Okay, so now, we have, no, that's it. We got rid of the variables on both sides. Now all we have to do is additive inverse and then multiplicative inverse. So let's use the additive inverse. I'm going to start going faster. If you don't understand it, then you're going to have to go back to the other problems because I'm getting tired of talking. So additive inverse of what? Of negative 32. $19 plus 32 is what? 51. Thank you. 51. Okay, and now I am going to, you know what? Fine. So I said multiplicative inverse. And I've said that we're going to multiply by, if you tell me now, what is the multiplicative inverse of 3, then I'll do it the easy way. Ah, you learn, of course. 3 can be represented as 3 over 1, so I would multiply the whole equation by 1 over 3. But since you guessed it, then I'm going to do it the easy way. 3 is multiplying x, so I'm going to get rid of 3 by dividing by 3 on both sides. Which is basically what would happen if I do the multiplicative inverse. Cancels out. X is, I have no idea. And let me see my hand. Oh, you cannot see my hand. Oh no. This is bad. Okay. Can you see it now? Yes, now you could see it. Okay. Woo! Thank God I have mirrors. Alright, so what is 51 divided by that? I have no idea. I think. Oh. 7. No. 17. Yes, 17. Okay, cool. Alright, so that's what it is. So I'm still gonna keep on using the multiplicative inverse, but now why have I been insisting on that? I'm gonna explain to you why. Okay. Boo! Yeah. Oh my God. Let's see. Do we have an easier equation here? Okay, somebody's getting wrecked over there. Okay. What was I gonna do? I forgot. Alright, yeah, I'm gonna do one the easy way, okay? Alright, so we got that one, right? Let me see if you can see that. Hopefully you can see it. Okay, so this is a multi-step equation because now we don't have just the two. Remember, the last two steps are additive inverse and multiplicative inverse. Here, we have, and always look at that. Do you have like terms on the same side? No. Like terms on the same side? No. So then, do we have variables on both sides? Duh. So this time, I'm going to do it a little quicker. If you don't understand it, just rewind it, right? Alright, so I have variables on both sides, and I'm going to get rid of the lesser one. The lesser one is between -5 and -7. -7 is less. So I'm going to add 7x to both sides. -5 plus 7 is 2, so I have 2x. Bring down the 22. Cancels out, becomes 0. Equal sign, and then this is 16. Okay. And now I have only two operations, multiplication and subtraction. So guess what? In any way, it's always the case. After you get rid of the variables on both sides property, you know, the VBS, then guess what? You're gonna use the additive inverse and the multiplicative inverse. Okay? Cool. So, additive inverse of what am I going to use? Please don't ever say, oh, you're gonna use the additive inverse of 16. 16 has nothing to do with the variable. No. We're trying to get rid of things that are bothering the variable. So the 22 is subtracting. Okay? It's subtracting the variable, or actually the variable is being subtracted by 22. So then, that's exactly what I'm gonna do. Additive inverse of -22, positive 22. So you bring down the 2x, right? And then 16 plus 22 is, I have no idea, so this is 8, and this is 3, 38. And now, the multiplicative inverse. What does the multiplicative inverse do? Get rid of this. So what is the multiplicative inverse of 2? Well, remember, this is 2 over 1. So I will have to multiply by 1 over 2. Okay, you know what? Let me do it. I'm going to multiply by 1 over 2, by 1 over 2. Okay? And what will this do? Easy. 1 times 2x is 2x over 2, of course, right? Equals to 38 times 1 is 38 over 2. So yes, it is the same thing as if you say, Becker, just divide by 2 on both sides. So okay, so basically that's what I did. But I did it through means of the multiplicative inverse. So anyways, 2 divided by 2 cancels out. X is, what is 38 divided by 2? Let me see, 16 and 16 is 32, 19. And that's it. That's your answer. All right then. So let's see now. Do we have two-step? Let's see, simple binomials. Okay, yes, I got that. I need more. Mix. Oh, is getting real. It's getting real. It is getting real. All right, let's do one of this. All right, so I'm gonna explain to you how to do these equations, and then I'm gonna have to go back to the small paper because, as you can see, I don't want to be wasting all this. Well, it's not really a waste because this is the ultimate video on solving linear equations. All right. So, should I give you the rules right now? You know what? Yeah, I'm gonna give you the rules. And it's not gonna be pretty, but I'm gonna have to do like an editing of all the videos to show you. Alright, so the first rule, I don't have enough space to write everything, but let me see, and actually let me just make sure that I got all the rules down packed, because if I make a mistake, everybody's gonna start killing me and blah 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 blah. Alright. So here we go. Can you read this? No, right, it doesn't matter. Alright. The first rule is make sure that if there is distributive property, DP, okay? Actually, you know what? Fine. Distributive property. Look out for that. That is the first thing you're gonna be looking out for. It's amazing, right? Now I'm gonna give you all the rules after I've been torturing you with all this. The second rule is that you're going to look out for any denominators. When you have a big equation, you're gonna have to look out for any denominators. So look out for denominators. And why? Well, if you have denominators, guess what? If you have denominators, if your answer is yes, then find the LCD. LCD means lowest common denominator or least common denominator, not liquid crystal display. No, that's not what it means. So don't get any ideas and don't get any jokes. So LCD, lowest common denominator, if you have fractions. If not, then chill. Got it? All right. And multiply the whole equation by the LCD. Number 3. check for like terms. Lettuce and tomatoes. Check for like terms. I'm not saying that there will be like terms. I'm saying check for like terms. But make sure that you check for like terms on each side. Don't be like, oh look, there is a 2x here, there is a 3x on the other side. No, that's not what I meant. I meant like check on each side, just like we've been practicing before. Check on each side. Are there like terms? If there are, then you combine them. If not, then relax. Because if you don't have like terms, that's why rule number 4 was created. Thank you. You're welcome. Do we have variables on both sides? If we have, then get rid of the lesser one. Okay. Get rid of the lesser one by addition or subtraction. Okay, you should be copying this down. It's not like I'm gonna be writing everything. Fifth rule. The fifth one is part of the last two rules. So use the additive inverse of the number adding or subtracting your variable or the variable. And this is one of the things that we've been practicing. Okay? Number 6. After the additive inverse, what's next? What have we been doing? Multiplicative inverse. How do you know we have multiplicative inverse? You will see a number multiplying the variable. As simple as that. After that, you're done. You complete it. You solve your equation. You're Gucci. You're good to go. Get it? I know this is long, but if you actually understand this, oh my God, it's gonna be awesome. Because we have some OD equations. All right, so look at that. Keep it in mind. I'm gonna keep on repeating what's going on. Don't worry about it. Let's see now. For reals now. Okay. So let's have one of those crazy equations. What are you? Bah. Se me perdió el papel. ¿Qué hizo el papel? Guys, I cannot find the paper. Oh, found it. Okay. And this is not even part of the lesson yet. Dímelo. Como querrás siempre. Dale, no le pare bola. Bueno, I don't know. I lost track, so I'm gonna call this equation number 17. We're good to 17? Yes? Alright. So this is what I have. Oh my God, I'm gonna die here. Alright, so I have negative 22 equaling 7x plus 2 times, there is no plus or minus here, so it's times, 2 times negative 7x plus 10. That's why I give you the rules, because it's gonna get crazy, it's gonna go down. So let's see what happens. What is the first rule that I showed you? Look out for distributive property. I think I made a video on that, on the distributive property, but just in case, this is what distributive property looks like. Something outside the parentheses, followed by the parentheses, and you have to like multiply by everything. Everything gets multiplied by everything. You float too, you float too. So let's see now, nothing happens here. So negative 22, okay, equals 7x is not part of this distributive property. It's the 2 that is part of this distributive property. So let's see now. Positive 2 times negative 7x is negative 14x. Oh look. Then positive 2 times 10 is positive 20. I'm done with the distributive property. Now, what was the other rule that I said? I said, look out, are there any fractions? I don't see any fractions. Let me zoom in just in case. Okay, so, all right, so let me zoom in. Okay, that should be good enough. Let me see. Bum. Yes. No fractions whatsoever. So you say no. So then, what was the next rule after that? Well, it says, are there like terms on the same side of the equation? Look, are there like terms on the same side of the equation? No, not really. Yes, like terms on the same side. Look, same side. Okay, so let's combine them. So I have negative 22 equaling 7x minus 14x is negative 7x, and then plus 20. Oh, okay. Next rule. What was it? Are there variables on both sides? This side, no, there's only variables on this side. Okay, cool then. So let's skip it. What's the next rule? The most famous two rules that you have. The additive inverse and the multiplicative inverse. So what is the additive inverse of what? On the side that the variable is, what is that number that is adding or subtracting? Right, it's the 20. So then I'm going to use the additive inverse of the 20, which is see that? And now correct? And the last rule was what? The multiplicative inverse. The multiplicative inverse of what number? Of 7 over 1, which is what? 1 over 7. So I'm going to multiply the whole thing by 1 over 7. Now, if you are used to the multiplicative inverse, then, and you don't want to do it like that, then remember 7 is multiplying x, so you could just divide by 7 on both sides, because that's the idea behind the multiplicative inverse. But if you're not used to it, then you're going to have to multiply the whole thing by 1 over 7 until you end up with this. If you don't understand it, then you're going to have to go back to the video. Alright, so we have x equal negative 6. Okay. So we're good with that? Yes. Let's try another one. Wow. Okay, how do I do this? Okay, here we go. Number 18. Okay, we got it. Oh, okay. I'm sorry. I gotta zoom out. Okay. So we got that. Hopefully that's enough. Let me see. No, it's not enough. Oh my God, it's not enough. Okay, hopefully that will be enough. All right. So we have 2 equals x over -5 minus 7. So that's what we have. Okay, so let's do a recap of all the rules that we need to use. So we need to look out, rule number 1, we need to look out for distributive property, then for fractions, then for like terms, then for variables on both sides. Number 5 is the additive inverse, and number 6 is the multiplicative inverse, okay? Now this has different interpretations because we could just like divide by the number. Alright, so let's see. Is there any distributive property right here? No, right? So then, we're done with that. Are there any fractions? Ah, yes! This one. And what is it that it says if you have fractions? You need to find the common denominator. Okay, fine. By the way, the calculator can actually find the common denominator for you. I will do another video on how to solve equations with the calculator. So let's see now. What is the common denominator? Well, let's take a look at this. The denominator here is a 1. The denominator here is a 1. So the only number that changes is -5. So what is your common denominator? Right. Your common denominator is basically -5. So what to do once you find the common denominator? Multiply the whole thing by the common denominator. Okay? So now let's see what happens when I multiply the whole thing by the common denominator. -5 times 2 is -10, right? Yes? Over 1, of course. Equals. Remember, we're multiplying sides, not just terms. Okay? So if I'm multiplying this side by -5, the whole thing gets multiplied. So let's start. So this is -5x over -5. See that? Plus -5 times -7, negative times negative is positive, 5 times 7 is 35 over 1. I'm not going to write the over 1, please. But now, let's see what happens. -10 equals x plus 35. Whoa, 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 how you got this x? Hello? -5 over -5. -5 divided by -5 is +1. +1 x plus 35. So anyway, so I got this, right? Now, let me ask the other questions. Do I have like terms on the same side of the equation? No? No. So, do I have variables on both sides? One here? Nope. So let's use the additive inverse. Is there a number that is adding or subtracting the x? The x is being increased by 35. So yes, let me use the additive inverse of that. Of course, I did that. Remember, using the additive inverse of the number that is bothering the x, not of the other number that is like, that has nothing to do with anything, right? So, minus 35. So that's -4. Oh, you can all see. You can all see. Oh my God. What kind of teacher am I? Oh, hell no. I mean, yes. Oh gosh. Okay, here we go. Please, now you can see. So then you got the 45 equaling x. Whoa, what about this? Hello, the opposite, so they cancel out. So my friends, Welcome to solving real linear equations using the golden rules that I have designed for it. Alright, so I am going to, should I take a break right now? Let me see now. Yes, I'm going to take a break, and next time I am going to go on to the paper because I don't want to run out of paper. I really used up a lot of sheets. Alright, see you. Bye. Okie dokie, so as promised, I said I wasn't gonna be using the other paper, so now I'm gonna go to the lesson. Well, the whole thing has been the lesson. So we're still on solving linear equations, right? So a couple of questions. The identity element of addition, what is it? And also justify your claim with evidence. Well, for addition, the identity element is 0. Why is that? Because any when you add 0 to any number, we get the number, the original number that we started with. So justification, okay, justification with facts, I would say, and I know I'm writing with my left hand, so I'm not trying to cover everything. Okay. Zero added to any number, okay, results in the original number. Plain and simple. You want an example? Well, the example would be example, right? And you write example. 3 plus 0 equals 3. 5 plus 0 equals 5. So you see we get back the original number and it doesn't lose the identity. Alright, so now let's move on to the next one. Although I did explain this at the beginning of the video, but still. The identity element of multiplication. We've seen this in September, so the identity element is 1. Reason being is that in any number, okay, or actually a number multiplied by 1 results in the original number. So that's what you need to write. Any number multiplied by 1 is itself. Okay? You want examples? Well, I give you examples, but this is not the only thing that you're writing. You're writing the justification, the written justification. So example, 3 times 1 is 3. Okay? Or 4, and I'm going to use the fancier version, 4 times 2. Oh, what? 4 times 1, I'm sorry. 4 times 1 is 4. A times 1 is A. X times 1 is X. So there you go, you have more than enough space. Alright. To multiply by 1/4 is the same thing as dividing by, well, is the same thing as dividing by 4 because, show proof, sure. Let's have a number, let's have 3, right? 3 times the quantity 1/4 is the same thing as, and I'm gonna make this rational number a fraction just so you could see. I don't have to, but I will. So, and we did this before. So 3 is the same thing as 3 times 1, and then multiply by 1/4. When you multiply straightforward, so 3 times 1 is 3, 1 times 4 is 4. You see? So it is the same thing as dividing by 4, because 3/4 is the same thing as 3 divided by 4. Oh, okay. Okay, we've been through this, so right now you should already been exposed to the explanation. So the additive inverse of any number is its opposite. Yes, it is true. I'm not even going to ask you. It is true. Now proof. Well, the proof is in the following. When no, not when. The sum so the sum of a number and its additive inverse equals the identity element of addition. I know I'm blocking, I'm sorry, I'm left-handed, but that's what I can do. So the sum of a number and its additive inverse equals the identity element of addition. I'm just trying to be fancy. And what is the identity element of addition? Which is 0. Okay? And the proof, sure, the proof is the following proof. Okay. 3 plus negative 3 is 0. Remember what 3 plus negative 3 means. 3 plus negative 3, remember that I hate seeing two signs together. So this is the same thing as saying 3 minus 3, which is 0. That's basically it. All right. Now you give more examples, like you could say b plus negative b is going to be 0 because a number and its opposite give you the identity element of addition, which is 0. Wow. Okay. So here, the multiplicative inverse or reciprocal, okay, of a number is found by flipping the fraction. Show proof. Okay, so if you're my student, you need to write down what I'm gonna say. If you're not, you could just understand the proof. So the product, okay, the product, in other words, the multiplication, okay, of a number and its reciprocal there you go. The product of a number, okay, and its reciprocal results in the identity element of multiplication, which in this case is what? Well, you have it up there, which in this case is 1. So you write that down. Now let me give you the proof. For example, if you have 3 over 2, the reciprocal of this is 2 over 3. When you multiply those, you get 6 over 6. 3 times 2 is 6, 2 times 3 is 6, and 6 divided by 6 is 1. See? That's the proof. Okay, I didn't want to use variables because, alright. So then this is a long text about equations, and when you were in like little ones and they gave you the box, I already explained that at the beginning of the video. So you have it right here. You could read it if you want to. If you're my student, you must read it. Haha. So anyway, so this is just explaining to you what to do, what not to do, how to undo the properties, which we already went through that at the beginning. Then you have the example right here. See that? And you have undoing the addition of 6 with a subtraction of 6. What you do to one side, you do to the other. Then you have another example over here. It says solve x minus 3 equal negative 5. So if we follow the rules that I gave you, remember the first rule is, do we have distributive property? And the answer is no, hell no. Then the second rule was, do I have fractions? And the answer is no. Third rule was, do I have like terms? The answer is no. Fourth rule is, we have variables on both sides. The answer is no. Fifth rule is, use the additive inverse, okay? And do we have additive inverse? In this case, we do. Look, x is being decreased by 3. Okay, 3 is being subtracted from x. So then I just have to use the additive inverse of 3, which is, of negative 3, which is positive 3. And then we have negative 5 plus 3 is negative 2. You could use the calculator to corroborate that, and boom. Now, the sixth rule was, do we have multiplicative inverse? But there is no number multiplying the variable, so we don't even have to get all the way there. Got it? There's another example on how you solve it. You could look at it because I already went through all this in the video. The reason for this one is to go over certain things that I didn't go through. All right, and the solution is negative 8. If you have questions why this is negative 8, you could do it. Now, the one step that I've been stressing is that once you have 7x equal negative 56, I don't want you to divide just by 7 on both sides. No, I need you to use the multiplicative inverse of 7, which is 1 over 7. Okay? Look, right here. Let's say you have the, let me see the pen. Okay. This is what you have. You have 7x equals negative 56. That is this step right here. That's what you have right here. So the 7 is multiplying the x. So I need you to use the multiplicative inverse of 7. Why? Because I need you to become acquainted with that. So look, 1 times 7x is 7x, and then over 7. So in other words, when you say divide both sides by 7, actually before that you were utilizing the multiplicative inverse. And look, negative 56 times 1 is negative 56 over 7 is negative 56 over 7. And then of course you divide, and you get x equals negative 8. But once again, stress on the multiplicative inverse. You're gonna thank me, because now I'm gonna tell you that there are equations that at the end you're dealing with a weird fraction or from the start. So there you go. Okay, so it says your turn. This time write down the variables. Where did I do my turn already? No, I didn't, but anyways, your turn. So what happens here? You have it in your handout. If you're not my student, then you have it right here. So the variable is being multiplied by negative 5. You see it? Then 7 is being subtracted from negative 5x. And hold on, I gotta answer the phone. Well, the person who's calling is not calling anymore, so it's okay. Alright, where was I? Alright, so this is a summary of what's going on. Okay? Then what will you do? Work backwards, undo. We spoke about it. So what am I gonna do? Add 7 to both sides. Uh-oh. So I add 7 to both sides. And then the easy way out is to divide by negative 5 on both sides. So since you are already used to the multiplicative inverse, I'm gonna pause right now and I'm gonna actually do the easy way, right? And that's what we get. X equals negative 23. All right, so now let's see how you do this. So here we are going to use academic vocabulary. So it is the same thing, but now what will I do? Well, use the additive inverse of negative 7. So you see, and then it says use the multiplicative inverse, reciprocal of the number multiplying the variable. So this time I'm going to use the multiplicative inverse, and you're already familiar with that. What is the multiplicative inverse of negative 5? It's 1 over negative 5. How? Because this is negative 5 over 1. Remember? Oh, yeah, Bax, you said it. All right. And remember what the idea behind the multiplicative inverse is to get rid of that number bothering the letter, the variable. So when you multiply and divide by the same number, they cancel out, leaving you with 1x. What you do to one side, you do to the other. So now 115 times 1 is 115, and then divided by negative 5 is negative 23. And that's basically what it is. Alright? Alright, let's do this. So, how many steps? How many steps? Multiplication and subtraction. That's it. Only 2 steps. So then, out of all the things that you're gonna do, okay, you could definitely go like, is there distributive property? And you go like, no. Number 2, do we have fractions? And you say, no. Number 3, do we have like terms? And you go like, no. Number 4, do we have variables on both sides? No. So it all comes down to 2 operations. And these 2 operations are nothing more than the additive inverse, okay? Additive inverse of what? First of all, you said yes. And you say, of what? Of negative 7. Which is positive 7. So we bring down the 4x. Negative 7 plus 7, okay, is 0. And then 13 plus 7 is 20. And then the last step is what? You gotta become acquainted with it. Multiplicative inverse. Of what? Of 4. And what is the reciprocal or multiplicative inverse of 4? Well, it's 1 over 4. But Bex, can we just divide by 4 on both sides and that's it? Well, yeah, that's the idea behind the multiplicative inverse. Oh, okay. So anyways, so when you multiply a number and its multiplicative inverse, you get 1, right? 1x. 20 times 1, 20 divided by 4, 5. Okay? Okay, here we go with this one. So let's see now. Once again, number 1, do I have distributive property? No. Okay. Number 2, do I have fractions? The answer is yes, we have fractions. We have fractions. Okay, we have fractions. So I'm gonna find the common denominator. Hello, Becker. There's only one denominator because the rest are 1 and 1. Oh, okay. So 38 is my common denominator. So I am going to multiply both sides by 38. So 38 times negative 8 plus b over 38, okay, equals to negative 9 times 38. Okay, remember we're multiplying sides, not just numbers. So on this side I have these 2 terms that have to be multiplied by 38. So it's like the distributive property all over again. Okay, so let's start multiplying. So what is 38 times negative 8? That's 304. okay, plus, remember here, you multiply by this one and now you're going to multiply by this one. Guess what? You're multiplying and dividing by the same number, so they cancel out, right? So that means that this is just b. Oh, back to the best. Equaling to, and now you multiply 38, okay, times negative 9, correct? And you get negative 342. Okay, so now so no distributive property, fractions, yes, and you know what to do. Find the common denominator, multiply the whole equation by the common denominator, then you proceed to step number 3, which is like terms on the same side, like terms on the same side of the equation. Okay, so let's see. Do I have like terms here? No. Do I have like terms here? No. So then now I'll move on to the 4th step. Variables on both sides. Nope, I only have b on one side, so no. Hey. And of course, let's look for additive inverse. Do I have additive inverse? Is there a number that is adding or subtracting? Of course. 304 is not being added to b. No, it's being subtracted from b. You have to understand that this is the sign of 304. So then I'm going to use the additive inverse of negative 304. What is the additive inverse of negative 304? Positive 304. And when you do to one side, you got to do to the other. So now the question is, what is negative 342 plus 304? I have no idea. I know that this will cancel out, so 0, bring down the b. And this is negative 342 plus 304. Okay, they have different signs, so I have to subtract them. So then this is negative 38, because when they have different signs, you subtract them and keep the sign of the number that looks bigger without the sign. Okay, got it. You're awesome. So that's basically what it is. That's how you solve the equations. All right. So I did solve it for you. I did explain to you, but remember what the instructions are. For this one, we're gonna have to divide ourselves into the conversations. All right. You got the placemats, and this basically doesn't apply if you're not my student. It only applies if you are my student. So how to conduct a conversation? Well, read it right here and let's follow the instructions. Each station should have 4 members and may be a group of 3. Each member chooses a number 1, 2, 3, or 4. Okay? 1 is going to be the speaker of the group. Then we have the placemats with the prompts placed in each station, okay, in each group of 4, for students to choose from, okay, as conversation starters. So anyways, so this is basically how you're gonna do it, right? Then after a while, the speakers will rotate to different stations. All right. What else? Then number 2 will become the speaker, and so on and so forth until everybody has gotten to be the speaker. So number 1 becomes number. Wait. Let me see. I don't know. All I know is that number 2 is gonna become the speaker, okay? And then number 3 becomes the speaker, and then number 4. So let's see now. What do we have here? Okay, so this is the prompt. All right. Unfortunately, I don't have a crazy person with me to talk to, so I could give you an example of it, but maybe I will in the future. So this is your prompt. Prompt number 1, prompt number 2. That means that you have a choice of problems. Okay. Now, what is it that you're supposed to do? Well, you're supposed to engage in academic discourse. So how does it work? Well, for example, this page, actually let me make it smaller because I'm explaining anyways. Wow, why am I explaining this? I don't know. So this, if you looked at the video ahead of time. So here you're gonna have 1, 2, 3, 4 names for the people in your group. Then you have your prompt 1 and prompt 2. You choose your prompt. Now 1, 2, 3, 4. The 4 members are going to ask questions to the speaker pertaining the prompt. Like, for example, and I'm gonna give you an example. I know that I'm not good at giving examples, but for example, okay, so this is an equation. Is this an equation? Yes, this is an equation. All right, so we need to solve this problem. How do we tackle this problem? Is there a process? Well, yes, there is a process. I believe that there are operations happening in here. And based on our knowledge of equations, if we know what an equation is, then we have to work backwards. Can you expand on that? Can you elaborate? What do you mean by backwards? Well, to expand on what I just said, what I mean is that, remember PEMDAS? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Well, we gotta undo, but going backwards. So instead of PEMDAS, and you can make a joke, right? Like, let's say you have, let's say, okay, speaker notes, speaker response. So if you have PEMDAS, right? And if you wanna go backwards, then you could write, oops, sorry, you could write SATMAP, which is backwards of PEMDAS. I don't know what SATMAP would mean. Okay, Sally, Aunt, dear, my, excuse, please. I don't know, whatever you want to call it. So this is the backwards. So then the speaker can continue, right? And it says, okay. So for example, here we have the operation of division and we have the operation of subtraction. So which one goes first according to PEMDAS? Well, division goes before subtraction and subtraction goes last. Okay, so then if we are undoing the operations, I guess we should undo the subtraction first. Yeah, but how do you undo the subtraction? Well, with an addition. Oh my God, you're right. You're great. Okay, I understand. And then the questions are written here. Let's say this guy, what's his name? I don't know. Just give me an Drake. Drake ask, what do you mean? What do you mean by undoing and working backwards?
Yes.
So basically, I like something like that. Okay. What do you mean by undoing and working backwards? And then, of course, here is where you record what the speaker set up, what the speaker responded to your question. You don't have to ask 1,000 questions; just ask one. Then the next member of your group asks another question to the speaker, and so on and so forth. Okay, until you can actually have an idea on how to tackle the problem. Then on the next page, oh my God, if you're not my student, don't worry about it. You don't have to like listen to all this. Once you ask the question, all that, and you have an idea, then you go to the next page, which is this one. So you have the prompt, and now it says mathematical evidence. So then written justification, okay, proof, property use, analogy. However you want to look at it, it all means the same thing. It means show work. Well, you got the golden rules to solve equations. So the first thing that you could say is, okay, mathematical evidence. So you start with your equation, right? And written justification. So we are going to solve this equation, okay, by undoing, okay, depending on what the speaker said, right? Or based on our knowledge of the rules to solve linear equations, first we are going to look for distributive property. Okay, and we can see that there is none. Then we proceed to explore to see if there are any fractions, and we find that there is a fraction here, b over 38. Therefore we need to find the common denominator. Well, since all denominators are not there, since there are two denominators of 1 and 38 is the only denominator that changes, then 38 becomes our common denominator. If not, then we will have to play the game down to 1 or find the common denominator however we see fit, or however you see fit, okay? Because there are many ways of finding it. Okay, then we're gonna multiply the whole equation by the common denominator. Okay, and anyway, if you have this handout, you know what to do. Once you do that, then you go to the next rule. Then we are going to look for like terms, and we see that there are no like terms on each side of the equation. So therefore, we're going to proceed to find out if there are variables on both sides. You see, that's how you are going to, oh my God, I wish you could see my face because it's really like corny. That is how you're going to justify your analogy. That is how you're going to provide complete evidence, proof, properties used, written justification. This is the perfect example. See, simple question, simple prompt, solve this. And that is going to create a world of exploration. All right? So anyways, so let me stop right there. You already got the idea. And let me go back to where I was, because we need to solve this. All right, so let's go over here. I'm gonna go a little faster. This is where you write your justification. I am not going to write the justification. I am going to just say it and solve the equation. You write the justification. So first, I'm going to look for distributive property, and I find none. Then I'm going to look for fractions, and I see that there is a fraction here, so I am going to find the common denominator. Well, 3 is the only denominator here, so that's the common denominator, so I'm going to multiply the whole thing by 3. Remember, we're multiplying sides, not just numbers, so multiply by 3. So 3 times n is 3n divided by 3, okay? So that's 3n divided by 3, plus 3 times 6 is 18, okay? Equals 3 times 9 is 27. These 3's cancel out. So basically, I mean, I should have canceled them out or over here, because I already said it. When you multiply and divide by the same number, they cancel out. So now, oh my God, if I'm speaking too fast, then you could just slow down the video on YouTube. All right, so I didn't do anything. All I did is copy this with the cancellation of the 3's. All right, so fractions taken care of. Next rule, do I have like terms? Okay, so I just wrote all of them. If I don't need them, if I don't use them, I don't use them. All right, so I got take distributive property taken care because there was none. Fractions, there was a fraction, so I multiplied the whole thing by the common denominator. Like terms, do I have like terms on each side of the equation? Well, this is one side and this is the other side. No, I don't have any like terms. Okay, do I have variables on both sides? Nope. One here but not here, so taking care of variables on both sides. Then additive inverse, if there is there a number being added to the letter? Hell yeah. Look, positive 18. So positive 18, that means that I'm gonna use the additive inverse. What is the additive inverse? Okay, this cancels out, and 27 minus 18, I have no idea. I think 27 minus 18, wait, hold on a second. 27 minus 18, I know what it is. That's 9. So my friends, your answer is 9. You see, this is the mechanical way, but at the same time, it follows a logical sequence on how to solve these equations. All right, let's take a look at this one. This one, oh, look, beautiful. this has to do with, well, that's it. So rule number 1, do I have distributive property? My answer is hell yeah. I mean, not hell yeah, but yes. The answer is yes. So look, 5 times x is 5x, 5 times 8 is 40, equaling 35. Second rule, you know what, I'm just gonna write them over here. Alright, so these are the rules. So let's see now. Fractions, nope. So no, right? Like terms on the same side, nope. Variables on both sides, nope. Additive inverse, is there a number being added to the letter? Yes. So additive inverse of 40 is negative 40. Then 5x equals 35 minus 40 is negative 5. Now multiplicative inverse of what? Of the number multiplying the letter. So what is the multiplicative inverse or reciprocal of 5? Yes, 1 over 5. So now a number times its reciprocal or multiplicative inverse cancels out. Negative 5 times 1 is negative 5. Divided by 5, negative 1. See that? And basically that's what it is. Okay, what else? Let me see now. How much more do we have? Wow, it's a lot. Okay, not a problem. I'm gonna have to take a break and then continue with this because my machine is going dead. So I'll do it. Okay. All right. So let's continue with this. That's it. By the way, my dog is like under the chair. So if I move, anyways. All right. So we have the equation 27 equals to negative 25x plus 18x minus 8. So let's see now. Let's write down our action plan. This time, I'm not gonna write what's going on. I'm gonna write the rules. Remember, that's basically your depth of knowledge explanation. So, for example, what is the first thing that we need to look at when we solve linear equations? Do we have distributive property? And I don't see any number, any parentheses being trying to be multiplied. So no. All right. So then, do I have fractions? So fractions. Now you have to write distributive property. I don't have to write distributive property. I just write DP. Fractions. No. Okay. The next thing is what? Do I have like terms on the same side of the equation? Well, this is one side and this is the other side. So here I notice that I have negative 25x and I have positive 18. So therefore I do have like terms. Wow, finally. So now you tell me, what is negative 25 plus 18? Negative 25 plus 18 is negative 7. So that means that this, when I combine them, I get negative 7x. Okay, so I write down 27 equals to negative 7x minus 8. So far so good. Okay then. So like terms, I did have like terms. You have to write like terms. And what were the like terms? The like terms were negative 25x and 18x. Okay, those were the like terms. So we're Gucci with that. All right, what else? What's the next thing I have to look for? Variables on both sides. Do I have variables on both sides? Nope. So therefore, I write no. Then the next thing is the additive inverse. Do I have additive inverse? Is there a number that is being increased or decreased by the variable? Yes, look. Negative 7x is being decreased by 8. So 8, I need to use the additive inverse of negative 8, which is positive 8. And remember, what you do to one side, you do to the other. I'm not gonna put plus 8 on the under the 7 because that's not where the other side is. The other side is over the equal sign. So, all right. So this cancels out. I copy down the negative 7x. And now what is 27 plus 8? There you go, 35. And now I am going to use the multiplicative inverse of the number multiplying the variable. In this case, negative 7 is multiplying x, so negative 7. What is the multiplicative inverse of negative 7? Well, which is negative 1 over 7. Remember, this is negative 7 over 1. So then the multiplicative inverse or reciprocal should be negative 1 over 7. So I'm going to multiply the whole equation by that. And you know what's going to happen, right? So I'm going to multiply by negative 1 over 7. You could say 1 over negative 7, negative 1 over 7, or just negative and then 1 over 7. However you want it, it's still the same thing, however you do it. Okay, so we get that. Now what? Well, what's the idea behind multiplying by the reciprocal? To cancel out. Look, when you multiply by negative 7 and divide by negative 7, they cancel out. That leaves you with your x. Whoa, that leaves you with your x. No, that's not right. Okay, so now look, negative times positive is negative. So my answer here is going to be negative. Now 35 divided by 7 is 5. So my answer is x equals 5. X equals, negative 5, not 5. Okay, and that's it. That's basically what you do. All right, so on the next series of problems, if you're my student, you need to write down the steps and in full sentences. You want to write it down a paragraph, a proof, then that's fine. But if you're not, then you could just solve the equation but still follow the golden rules. They will never fail you. Okay, so then let's solve the next one. And this time I'm gonna start going a little faster. If you need to, you could pause it, you could rewind it, but I still need to go a little faster. Okay. Oh, okay. So let's see now. All right. So let's see now. What you write in here is your action plan. So I start with: do I have distributive property? No. Do I have fractions? No. Do I have like terms on the same side of the equation? Yes. 5x and 7x. So I'm going to combine them so they become 12x. And now I continue. You see, once you get the hang of it, you could skip the steps because you will already know what to do. All right, so then do I have variables on both sides? No. Do I have additive inverse? I don't see any number being increased or decreased by the variable. So then the next one is the multiplicative inverse. Yes, of 12. I know what you can say. Becker, why don't we just divide by 12 on both sides? Definitely we can divide by 12 on both sides, but once again, for the purposes being, I need you to use the multiplicative inverse the way it's supposed to be used. Okay, so now remember, the idea behind the multiplicative inverse is to cancel it out. And we already seen that. 1 times 12x is 12x. Over, or if you want to put a 1 under here, it's fine. 1 times 12x is 12x, and 12 times 1 is 12. Okay? And then on the other side, 72 times 1 is 72 over 12. You see that? That's basically what you were telling me. Divide both sides by 12. But once again, the idea behind dividing by 12 on both sides is because you use your multiplicative inverse. I know it sounds corny, I know it's bothersome, but hey, what can I do? Anyways, I don't know what 72 divided by 12 is, so 6. Oh, okay. We got that, right? Cool then. All right, let's go here. So what do I have? I have this equation, and now I have to figure what to do. So once again, what is the first rule that you have to look for? Correct. Is there a distributive property? And you write it down right here, okay? You see, write down your action plan. Even if you are not my student, you could write it on loose leaf or whatever. All right, so distributive property, yes, I see a number followed by parentheses. Therefore, I have to multiply. You see, there is no plus or minus here, so that means multiplication. This -2 has nothing to do with the distributive property. Okay. Then what was that? Fractions. I don't have fractions. Like terms. Well, I do have like terms right here. See that? They're just numbers. Variables on both sides? No. Okay. Additive inverse. Well, is there a plus or a minus between the letter and a number? In other words, is the x being increased by a number? Yeah, it's been increased by 6. Oh, okay, so use the additive inverse of 6. All right, and then we're gonna use the multiplicative inverse of 8, which is 1 over 8. Remember, this is 8 over 1, so multiplicative inverse is 1 over 8. Okay, cool then. So then what do we get? Well, -28. The idea behind the multiplicative inverse is to get rid of the number that was multiplying the variable. Multiplying by 8 and dividing by 8 is the same. They cancel out, so that leaves you with x. On the other side, you get -28 over 8. And now it's funny because now, wait, hold on, maybe this is wrong. No, it's not wrong. I mean, it's okay to get a fraction, which is a decimal, which is a rational number. So let's take half of 28. What's half of 28? That's 14, right? And half of 8 is 4, correct? And now half of 14 is 7. So -7, and half of 4 is 2. That's it. It cannot be reduced anymore, so that's what x is. -7 over 2, 3.5. All right? Oh, hell no, that's too easy, too easy, too easy. Oh my God. So here, oh, let's see. No distributive property, no fractions, no like terms, no variables on both sides, no additive inverse. So therefore, just multiplicative inverse. But if you got the hang of the multiplicative inverse, then I'm gonna let you slide and we're just gonna do it the easy way, okay? So here, I'm just gonna divide by 2 on both sides instead of multiplying by 1 over 2. So 2 cancels out and x is 3, okay? All right, this is the moment you've been waiting for. There are 2 ways of solving this. Now look. Hopefully I can do this. 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 Give me a second. Give me a second. Okay. Look. For example, do I have distributive property? No. Do I have fractions? Yes. Okay. So if I do have fractions, I'm gonna have to multiply by the common denominator. In this case, the common denominator is 3. You know what? Let's just do it right here. I want to show you. Oh, okay, right. So I'm going to multiply the whole thing by the common denominator. So I'm going to multiply the whole thing by 3 because that's the only denominator. Okay, so let's see now. If I multiply by the common denominator, I'm multiplying by 3. So 3 times 2 is 6. Equals to 12. Now 6 divided by 3 is 2. And we still have the x, right? And now we divide both sides by 2. And this is 6. If you didn't follow, oh shoot, sorry. Okay, that's better. If you didn't follow right now, then just write down the rules and do it the way I've been teaching you. Once you get the hang of it, then you could start doing it this method. All right, so what happens is that I didn't have any distributive property, but I had fractions, so I multiplied by the common denominator. So I did, and it came out to be 2x equal 12. Then of course I went down through the other rules. Like terms, no. Variables on both sides, no. Additive inverse, no. Multiplicative inverse, yes I do, because I do have a number multiplying the x, but since we want to be lazy, I just divided by 2, because that's the idea behind the multiplicative inverse. Okay, it will cancel the number and it will basically provide us with the answer. All right then, the other way I wanted to do it is the following. So I'm gonna rewrite the equation. 2/3 x equal 4. Let's say I forget about fractions. Let's say I went to distributive property, then fractions, and I forgot, and I said like terms, then I said variables on both sides, no. Additive inverse, no. Then guess what? If the equation is as simple as this one, and I got to the last step, which is the multiplicative inverse, then look what happens when I use the multiplicative inverse. Well, what is the multiplicative inverse? Well, of 2/3 must be 3/2. Okay? And now watch what happens. Multiplying by 3 and dividing by 3 cancel out. Multiplying by 2 and dividing by 2 cancel out. In other words, 3 times 2 is 6. 2 times 3 is 6. So 6 divided by 6 is 1. 1 what? 1x. And now 4 times 3 is 12. Divided by 2? 6. Same thing. So that's why I always urge you, like sometimes you forget about the fractions and you end up with a fraction on the variable that you want. Then guess what? The multiplicative inverse will bail you out. All right, so now you know something that I hadn't explained before. All right, so let's move on to the next one. Once again, look at this. Simple fraction, okay? I could use all the rules. I could say, okay, do I have distributive property? No. Do I have fractions? And I could say yes. But look at the format. It looks like the other equation. A fraction x equals a number. A fraction x equals a number. So I could just multiply, okay, 4/7x equals 4. I could just multiply by the reciprocal or multiplicative inverse of this one. You see that? Boom, 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 boom. So now, please, I don't want to confuse you. If you start to get confused, then use the method with all the rules and follow them. Okay, tip to toe. All right. So 7 times 4 is 28. 4 times 7 is 28. They cancel out. Leaves you with x, right? Okay. Now, multiplying by 4 and dividing by 4, they cancel. That means they become 1. 1 times 7 is 7. Simple as that. Of course, now I give you the golden rules, blah, 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 blah. You already know. You know what? If you're not my students, I'll put them right here so you could read them. Okay, there you go. You got them. You could pause them, whatever. Let's go on to, and of course, then I provide you with an example on how to do it. See that? Okay. Cool then. So you see, distributive property, yes, and I give you the example right here. Then I solve it. At this point, you already know what's going on. I'm just showing you the example. And you see when I use the multiplicative inverse of 12, which is basically 1/12. So I multiply by 1/12, and I end up with my answer. Cool? Sure. Okay. So then, what do we mean by consecutive integers? All right. This is what happens. Consecutive integers are nothing more than numbers that go by ones. Like for example, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 right? Okay. Now, if you don't know the numbers, then you could use a variable. Like for example, if you don't know, okay, so if unknown if unknown, then the first number will be x or n or a variable. The second number is the gap between one number and the other. They go by ones, so the next number is going to be x plus 1, x plus 2, x plus 4, and so on and so forth. Okay then. Now, how about consecutive even numbers? Well, what are even numbers? Numbers that are divisible by 2, right? So, boom, 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 boom. But if you don't know, when just representation of the number, let's say the first number is always going to be x. The second one, well, what is the gap between the numbers? They go by 2s, right? So then the next number is x plus 2. The next one is going to be x plus 4, x plus 6, and so on and so forth. Funny thing now is that we're talking about consecutive odd integers like 1, 3, 5, 7, 9, and so on and so forth. Well, if you don't know it, you could always represent it with a letter. And then remember, this is the representation of the numbers, like the gap between numbers. This is not really an odd number. This is the representation. So the odd numbers go by 2s as well, right? So the next number is going to be by 2. So x plus 2, x plus 4, x plus 6, and so on and so forth. The reason I say that is because when you look at this, you're like, wait, hold on a second, but you represented the odd integers and the even integers the same. Well, yeah, because they go by 2s. They have the same gap. Got it? All right then. So that's it. Oh, by the way, the number before x, like the first one, it will be what? X minus 2. And this one will be x minus 4. So we're talking about the negative numbers, right? Minus 4, minus 2, plus 0, plus 2, plus 4, plus 6. If you have any questions, you can ask me. I don't have a problem with that. I'll answer. Alrighty, back to more equations. Hopefully by now you should be acquainted with this. So anyway, for the purposes being, I'm going to continue following the golden rules of solving linear equations. So, all right, if you're my student in here, you write like, what is the problem asking me to do? How will I answer the problem? What steps do I need to take in order to answer the problem? I will use the following rules to solve linear equations, and then you start labeling the steps, okay? And me, I'm just gonna solve it, still using the golden rules, but all right, so let's see now. Do I have distributive property here? Yes, so then negative 3 times 2 is negative 6, and negative 3 times x is negative 3x, which is minus 3x. The negative 5 is not part of this, so minus 5 equal 22. And then I am going to go on to the next rule, okay? So the first one was distributive property. The second one is fractions. The third one is like terms. Like terms, not like eyes. The fourth one is variables on both sides. The fifth one is additive inverse. The sixth one is multiplicative inverse or reciprocal. So you see, I write them all down. It doesn't mean that I'm gonna use them all. So distributive property, check. Okay, so yes, there was. Fractions, no. So no. Like terms on the same side. Well, this is one of the sides. So are there like terms? Yes, I have negative 6 and I have negative 5. So that makes it negative 11, right? Minus 3x. And then equal 22. Now, variables on both sides? Nope, 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 nope. Then do I have additive inverse? Well, think about it. You have negative 3 times x. That is not additive inverse. Is x being decreased or increased by something? Sure. X is being decreased by 11. Remember, this is not the sign for this number. This is the sign for this number. If you want me to rewrite it in a different way, I'll do it. I'll put the negative 3x first and then the minus 11 later. All right. So now you could see that x is being decreased by 11. So I'm going to use the additive inverse of 11. By now you must be tired. You must be saying, yeah, okay, I got the hang of this. I'm Gucci with this. And now I'm going to use the multiplicative inverse of -3. I know what you're saying. I could just divide by -3 on both sides. I get it. I perfectly get it. And at this point, if you have mastered that, then you're more than welcome to do so. Me, I'm going to still use the multiplicative inverse of -3. Remember, this is -3 over 1. So that means that I'm going to have to use 1 over -3 or -1 over 3. It doesn't matter. The thing is that it has to be negative. See that? I know. You asking me, Becker, which one is negative, the 1 or the 3? It doesn't matter which one. In a negative fraction, one has to be positive and the other one has to be negative. Or one negative and the other one positive. So that's why when it's like that, you just put the negative in the middle, like where the division of the fraction is, okay, between the numerator and the denominator, and it's still negative. So anyways, let's go back. So negative times negative is positive, right? And anyways, what is the idea behind the reciprocal or the multiplicative inverse? To cancel out the numbers and leave you with the variable that you want. Okay, positive times negative is negative. 33 times 1 is 33 over 3. So 33 divided by 3 is 11. And boom, we got it. Here we go again. Alright, so do I have distributive property? Yes. Too much talking. Okay, so -2 times 3 is -6x. -2 times -2 is +4, then plus 4x equals 11. Do I have fractions? No. Do I have like terms? Maybe. Okay, so those are the like terms. Cool then. So -6x plus 4x is -2x, and then plus 4 equal 11. Now, do I have variables on both sides? No. Additive inverse? Yes. Look, the x is being increased by 4. So I'm going to use the additive inverse of +4, which is -4, and we get -2x. This cancels out. 11 minus 4 is, I have no idea, 7. And now I am going to use the multiplicative inverse of that, which is what? -2 over 1, so it should be 1 over -2, right? Or negative, and then in between the fraction, like that. Alright, so the idea is that when you divide and multiply by the same number, they cancel out, so that's 1x, so x. And now, positive times negative, negative. 7 times 1, 7. Divided by 2 is -7 over 2. I know what you're thinking. Yeah, but that's -3.5. Yeah, but this is high school. Just leave it as a fraction, okay? Don't worry about it. Alright, let's move on. Alright, so as I progress, I'm going to start using, you have to justify the steps. I'm just going to solve the equation.
Number 4 is focusing on sleep. You see, a lot of us put sleep by the wayside, but we have to realize that sleep is what optimizes the hormones that I just mentioned before, which therefore...
I keep on writing like terms as LI. It's LT.
He's getting the right coach. You see, it's one thing to have a coach that looks the part, but it's another thing to have a coach that looks the part, but also backs everything with science, because you don't want to end up with a coach...
Okay, so I'm going to start.
...what he used to get in his own good shape. You have to have someone that can understand principles for everybody and truly understand science. So if you want to learn more, I created a free full-length video that gives you the...
Okay, somebody, this is too much talking. What's going on here? Man, what happened to my video that I had? It was nice, OD nice.
Just flat.
Okay. So now what? I'm gonna go straight to no fractions. Like terms, okay. 14 plus 11. Variables on both sides, nope. Additive inverse, yes. The additive inverse is not the 21, guys, it's the 25. Negative 21x is being increased by 25. So I'm gonna use the additive inverse of 25, which is negative 25. All right, distributive property, no fractions, no like terms on the same side, variables on both sides, yes, so get rid of the lesser one by adding or subtracting. 4x minus 1x, 3x, bring down the 5. Then we have additive inverse here. I mean, okay, we don't have fractions, we have variables on both sides, we have additive inverse, yes. And now, the moment you've been waiting for. I'm gonna use the multiplicative inverse, but I already know that I use the multiplicative inverse, or I could just divide by 3 on both sides. Yes, but then again, from here I could just say the following. 3 times what is 12? 4. See that? We know we're gonna divide, so x is 4. We still have to write the steps though. Alright, here we go again. So anyway, so this is basically for my students, and this is basically the Socratic the academic discourse. Write down the names of the people in your group, okay, and start asking questions to the speaker to see how do you tackle this problem. What do you see? You see fractions. Is there a way to solve it? How would you do it? Okay. All right, so we are still solving this problem because I don't see it anywhere else. Let me see. Nope, I don't see it anywhere else. So this will be one of the few problems that I am going to answer. But first, take a minute to figure out what you need to do, okay? Kobe! Alright, so you figured it out? Kobe? Kill me, Kobe? Are you kidding me? Oh my god. I don't want to step on your paws. Oh my god, if you could see my dog, he's like under, like if I move, I will squash his paws. Okay, sorry. Okay, so you took a moment or two to think about it. Okay, cool. So let's see now. Let's first write down the problem. Alright, so that's the problem. So let's follow the same rules. Do I have distributive property? And it's funny because we might not. Do I have distributive property? Nope, I don't see any yet. Do we have fractions? Yes, we do have fractions. So then guess what? We have to find the common denominator. Cool then. So how do I find the common denominator? Well, you could play the game down to 1, which is basically write down the denominators, okay, and start dividing by numbers. Like for example, what is the lowest number I can divide by here? Well, the lowest number is 3. Now 15 divided by 3 is 5. Okay, well, we're good. 3 divided by 3 is 1. And that's it. We see, once the number is down to 1, we cross it out and we're good. Now 5 divided by 3 cannot evenly go into 3, so then we just write down the 5. Then what is the next lowest number we can divide by? Definitely not 3, definitely not 4, but 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And now our common denominator is the multiplication here, which is basically 15. Okay, so what am I going to do with that common denominator? I'm going to multiply the whole equation by that common denominator. So let's see now. 15 times 2x divided by 5, right? That's how you read it. 15 times 2x divided by 5. Or if you want to put a 1 under, then you could do 15 times 2x and 1 times 5. What's up?
Hello.
Hi. So then, this is not a negative, okay? So let's see. 15 times 2x is 30x. over 5, correct? Then, oh my God, look, we're on the second step, which is fractions, but all of a sudden, now we got distributive property all over again. Why? Because we have to multiply the whole equation by the common denominator. So we already multiplied by this, now I'm gonna multiply by this one right here. So 15 times 1 is 15, and it's positive, so 15 times 1 is 15 over 3, right? And then here guys, I could multiply by 15 here. You know what, let me do it. I'm gonna show you two different ways of solving this problem. This is the hard way. 15 times 7, right? 15 times 7 is 105, so this is 105 x, okay, minus 30, okay, over 15. All right, now this is one of the processes that you won't have to do in the future if you just follow my lead. So anyway, so let's basically simplify this. 30 divided by 5 is 6x. Then 15 divided by 3 is 5. And then 105x minus 30 divided by 15. 105 divided by 15 is 7. So we have 7x. And then minus 30 divided by 15 is negative 2. Okay, what do you notice? When I simplify this, I ended up with this one. Why? Remember what I said? When you multiply and divide by the same number, they cancel out. So you would have been left with 7x minus 2. Here, it would have been easier to, instead of multiply by top and divide by bottom, we started with the division in the bottom. Look, 15 divided by 5 is 3. Times 2, 6. 15 divided by 3 is 5. Times 1, 5. So hopefully you understand that, so in the future you could apply it. All right. So now I did distributive property, I did fractions. Do I have like terms? Nope. Nope. Do I have variables on both sides? Yes. So get rid of the lesser one. So we have 5 equal to 7x minus 6x is x minus 2. Okay. And now I'm going to use the additive inverse of the number. You know, x is being decreased by 2. And now x is, oh my God. See, I need to move the camera and look at the camera. All right, so we have 5 plus 2 is 7. This cancels out, so x equals 7. As simple as that. So you see, we just turn a really difficult equation into something easy by following the golden rules. All right then. Let's see now. Oh, it's okay. We got more problems here. Gosh. All right, no problem. So once again, this one you could do on your own. Still, always remember to write down the rules. Here I'm gonna skip to the last one. I know I could use fractions, right? I could use the property, the second rule, the second golden rule that reads fractions. But I'm just gonna skip to the multiplicative inverse, if you know what I mean. Because there's only, look, one number multiplying the variable equaling to another number, so that should be easy. There is no other operation like a plus or minus, so then we're good. So multiplicative inverse of negative 1 over 3 is negative 3 over 1, right? Or just negative 3. Remember what the idea is. When you multiply and divide by the same number, they cancel out. And negative times negative is positive, so y equals, what is 15 times negative 3? Oh, you didn't copy, I'm sorry. Okay. And here you write down the steps. Okay, let's continue with this. Okay, I don't like this crazy. Alright, so we are going to solve this problem. I had written something previously over here, so I'm going to explain what is it that I'm doing. So here I said, okay, distributive property, no. Then I said, do I have fractions? And I said, yes, look, fractions. So then I'm gonna find the common denominator. So I put the two denominators here and I said, what is the lowest number I can divide by? And I put a 2 here. So 4 divided by 2 is 2. 6 divided by 2 is 3. Ah, okay. And then what? Then again I said, what is the next lowest number I can divide by? And then I said, wait, I can still divide by 2, so I divided by 2. 2 divided by 2 is 1, so hey, I'm done with this. And then 3 divided by 2 is, wait, 3 cannot be divided by 2, so I just copy it down again. Now, what is the next lowest number I can divide by? Well, I can divide by 3. Look, 3 divided by 3 is 1. So, boom, I'm done with it. That's great. So now, I have to multiply this and I find my common denominator. Although I already knew that my common denominator was going to be 12. Look, 2 times 2 is 4, times 3 is 12. So I am going to multiply the whole thing by 12. Okay? Remember, I'm multiplying by the top and dividing by the bottom. But it's easier to start dividing. Okay, look, multiply by top, divide by bottom. It's always the case. So let's see now. 12 times 5 is 60, and then divided by 6, you see? So then it's easier to say 12 divided by 6 is 2. Times negative 5 is negative 10. X. See how easy it was? And now 12 divided by 4 is 3, times 3, 9. I could have said 12 times 3 is 36, divided by 4, and then I would have to guess, and then, not guess, but think, and then I said 9. Alright, now I'm going to use the multiplicative inverse. So, because there's a number multiplying the variable, so multiplicative inverse of negative 10 would be negative 1 over 10, or 1 over negative 10, however you want to look at it. Like that. Alright, remember negative times negative is positive, and the idea behind using the multiplicative inverse is to eliminate the number on the variable. Alright, so multiply by top, divide by bottom, so 9 times 1 is 9 over, I get 10, right? I guess 10. Now, positive times negative is negative, so we're done with this. Remember, you gotta write the steps over here. Alright, let's move on. Alright, here, a plain side, I know I have like terms on the same side, so that's exactly what I'm gonna tackle. So 2 plus 3 is 5, 5 minus 7 is negative 2. And now, I'm going to stop using the multiplicative inverse. I'm still gonna use it, but I'm gonna follow what you guys like, okay? Which is basically divide by negative 2 on both sides. Okay, it's not gonna happen all the time, but right now, yeah, we'll do that. Okay, distributive property, no. Fractions, yes. So we are going to find the common denominator. So we could do it in 2 different ways. So we could play the game down to 1. Okay, so let's see, what is the lowest number I can divide by? 2, right? 6 divided by 2 is 3. 2 divided by 2 is 1. Hey, done. And 3 divided by 2, you cannot do it. So we bring down the 3. Next number I can divide by? 3. Okay. 3 divided by 3, 1. 3 divided by 3, 1. Hey. And multiply this, and that is your LCD, your least common denominator. So that means that I'm going to multiply the whole equation by 6. See, I'm repeating over and over what we're doing until you understand it. Remember, I could put this as 6 over 1 if it makes more sense to you, but then you will have to multiply it and then write it down over here. Multiply it, write it down over here. As opposed to if I just say, okay, we're multiplying by 6. So remember, when you multiply by a fraction, you multiply by the top and divide by the bottom. Multiply by top, divide by bottom. Okay, so then, but it's easier to start the division than the multiplication. So look, 6 divided by 3 is 2, times 2, 4. 6 divided by 2 is 3, times 1, 3. 6 divided by 6 is 1. Well, they cancel out. So times 5 is 5. So, see that? Easy, right? Now it turns into a simple equation. Additive inverse, because I don't have variables on both sides, I don't have like terms. What in the world did you just do, Becker? Well, I use the multiplicative inverse of 4, which is 1 over 4. 1 over 4. Okay. Well, then I said, okay, 4 times 1 is 4, divided by 4 is 1. Or 4 divided by 4 is 1, times 1 is 1. Or I just said when I use the multiplicative inverse on a number, they cancel each other. So that leaves you with x. And then 2 times 1 is 2 over 4. But 2 over 4 is the same thing as 1/2. Bam! Saving paper, saving 1 tree at a time. Let's see how much do I have left. This was a long lesson, oh my god. Alright, so by now you should be acquainted with this. That's it. Distributive property, no. Fractions, yes. So I want to get rid of this fraction because I don't really like to deal with fractions. So I'm going to multiply. What's the common denominator right now? The common denominator is 4 because that's the only denominator. So remember here, this 4 and this 4, they will cancel out. So that means that I'm left with 3x. Or look, 4 divided by 4 is 1 times 3, 3x. Plus 4 times 5 is 20. 4 times 2x is 8x. And 4 times negative 6 is negative 24. Then, do I have like terms? No. Do I have variables on both sides? Yes. So get rid of the lesser one. You see how easy this is becoming? So cancel out the 3x's. 8x minus 3x is 5x. 5x. Okay. And now what? Additive inverse? Sure. And now I'm going to use the multiplicative inverse. Or if you want to, in this case, we could just, you want to divide by 5? Fine, divide by 5. So we got x equals 44 over 5. Okay. This problem, I think this is the one we did on the... I think this is the one we did. Let me see, 15. Yeah, we did this before. Okay. The common denominator was 15. And now, remember when you multiply by a fraction, you multiply by the top, divide by the bottom. So 15, this time, I'm going to do it in a more simplified way. 15 divided by 5 is 3 times 2x, 6x. 15 divided by 3 is 5, times 1 is 5. When you multiply and divide by the same number, they cancel out. So you have 7x minus 2, okay? Then we have variables on both sides, so let's get rid of the lesser one. And now we use additive inverse. And x is 7. All right. So let's see now. Here, remember, this is where you start, right? Do I have distributive property? The answer is yes. So, or can I elaborate a plan to solve this equation? How am I going to tackle this? Well, first I'm going to use the distributive property. So guess what? I do have distributive property. So let's see. Multiplying by a fraction, multiply by the top, divide by the bottom. So this is like saying x over 1 if you like are confused. So x times 3, so it's 3x over 5. Okay, or 3 times x is 3x over 5, however you look at it. Then 3/5 times 2. Remember that this is also 2 over 1. So just in case you're confused, I would have just said 3 times 2 is 6 over 5. That's what I would have said, but it's okay. Oh, okay. 6 over 5. And then on the other side, remember that on the other side nothing happened. Okay. Whew. So we're good. Now I ask myself, are there any fractions? And I see that we have fractions here. So then I'm going to use the common denominator. So in this case, guess what the common denominator is? Yes, the common denominator is 5. So let's see now. Multiply by top, divide by bottom, remember? So 5 divided by 5 is 1 times 3, 3x. 5 divided by 5 is 1 times 6, 6. And then on the other side we have 5x minus 20, because 5 times blah 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 blah, right? You multiply by x, you multiply by -4, and that's what you get. Variables on both sides, yes, get rid of the lesser one. Additive inverse? Sure. Now we're gonna use the multiplicative inverse, but I'm gonna go easy on you and we're just gonna divide by 2 on both sides. So x equals 13, okay? Ooh. Oh, okay, here we go. Once again, here we have fractions. Now, you know what? I want to try solving the previous equation in a different way. I'm not sure if it's gonna work out the same, but
Hey, honey, can you look at this? Does this sound like me?
oh, okay. Let's see now. I'm watching movies. I'm watching chaga. Okay. So I want to try something. I'm not sure if this is gonna work, but if it does, then that will be a new trick to learn, right? I'm still gonna stick to my rules, but let's see now. So let's say I go and instead of saying is there distributive property, I actually say are there any fractions, and I see that there is this fraction over here. This is multiplying all this. So how about I multiply everything by 5? How about I multiply everything by 5? Then I would have 5 divided by 5, they cancel out, times 3, right? And on the other side I have 5x minus 20. So just hear me out. This is something that I'm just testing. So I did cancel out. I cannot go and multiply by this and then multiply by that and multiply by that, because this is the distributive property right here. This right here was the distributive property. So I'm multiplying the whole thing by 5, but this is already gonna get multiplied by 3 over 5. So I don't have to multiply by 5. You understand what I'm saying? It's like if I say, okay, 5 divided by 5 is 1 times 3, 3 times x. You understand what I'm saying? So by just doing it over here, you don't have to do it throughout the whole x plus 2. Now, if I use the distributive property, guess what, guys? It actually is the same. Wow. So I could have avoided using the distributive property over here and just do the fractions. Interesting. But I did have to make sure that if you know what, easy. If you want to do this in the future, you could just use the distributive property in the following way. So I did have fractions in conjunction with the distributive property, so I went like 5 divided by 5, 1. For in other words, this 5 cancels with this one, so that only leaves 3 times x and 3 times 2. Ah, that's why. Alright, anyways, the golden rules will never fail you. Let me try this again. I'm gonna do this the regular method. Alright. And then I'm gonna try with the method that we just discovered. So anyway, so distributive property, yes. So I have 1/2 x, okay, plus 1/2, okay, 1/2 times 1 is 1/2, minus 1/3 x, 1/3, negative 1/3 times x is negative 1/3 x, negative 1/3 times 2 is, well, this is like the same thing as 2 over 1, right? So when you multiply fraction, you multiply straight through. Or you could just multiply the 2 times the 1 over the 3. Anyways, so negative times negative is positive. 1 times 2 is 2. 3 times 1 is 3. Okay, this is the invisible one that I put in there. You don't have to do it like that. Okay, you could just say 2 times 1 over 3. Look, 2 times 1, 2 over 3. Anyways, so that equals 2. So I have fractions. And I know that my common denominator, if I play the game down to 1, is going to be 6. So I'm going to multiply the whole thing by 6. Okay, so now when I multiply by 6, what do I get? Well, 6 divided by 2 is 3, times 1 is 3. Okay, so I'm not even going to say it. I'm just going to do it. 6 divided by 2 is 3, times 1 is, what? What is wrong with this thing? 3 times 1 is 3, so minus, remember, we're multiplying by 6. There is no number multiplying inside here, so the 6 has to multiply everything. 6 divided by 3 is 2 times 1, 2, x, and then 6 divided by 3 is 2 times 2, 4, equals to 12. It's a long one. All right. Now, do I have like terms on the same side of the equation? You bet I do. 3x and negative 2x, so that's 1x. Then 3 and 4, that's 7. Okay, and now that's 12. And then it turns into the easiest equation in the world. You know how to solve this. I'm not going to solve it for you, or maybe I will. I'm going to use the additive inverse. 12 minus x is 5, so x is 5. Good. Now, I want to try solving this equation using the method that we discovered before, this one. I'm not sure if that works, but let me rewrite the equation first, okay? So 1/2 times x plus 1 minus 1/3 times x minus 2 equal 2. All right. Okay. Instead of using the distributive property, I am going to use the fraction. So I'm going to multiply by the common denominator, which is 6. Okay? 6. Let's see what happens. It's gonna be fun. Let's see if this makes it easier. Remember, once you do the operation over here with the 6, you don't have to do it over here. Once you do it to the 1/3, you don't have to do it to this one. Because remember that after you do it to the 1/3, whatever, the 1/3 was gonna do it to this one. So it's still gonna happen. So there's no need for the 6 to go all the way. So let's see. 6 divided by 2 is 3. So 6 divided by 2 is 3, times 1 is 3. So I'm gonna end up with 3 times x plus 1. Hopefully it makes sense. And then this one, there was another distributive property here. So 6 divided by 3 is 2, times 1, 2. So this was gonna turn into, I just hope you understand, and by no means I'm trying to trick you or confuse you more. I'm just trying to find an easier way to do it. So now I end up with something without fractions. Just gotta make sure that you don't do the 6 to everything. You gotta make sure that you understand that you only do it to the beginning of the distributive property, the number that is multiplying, okay? The number that is going to be distributed. All right, so let's see what happens when I simplify this. I get 3x, okay, plus 3 minus 2x plus 4 equal 12. My friends, I think it works. I think it works. All right, so that's it. I'm not gonna do the rest because you already have the answer there. All right, so this is the last page. I don't think I need to do anything here. I definitely don't. So I mean, we could solve this one, but I want to show you. No, I'll do it. All right, so we have distributive property. So 6x plus 4 minus 4x minus 4 equals to 2/3. We do have fractions, but the only common denominator here is the 3. All right, so let's multiply everything by 3. So I'm gonna multiply the whole thing by 3. So I get 18x, okay, plus 12 minus 12x minus 12, okay, equals to 2, because 3 divided by 3 is 1, times 2 is 2, or 3 times 2 is 6, divided by 3 is still 2. Okay, and then from there you don't need any help. No, actually you do. Let me finish this, because then I gotta make another video, a short video. All right, so we have like terms. So 18 minus 12x is 6x. 12 minus 12 is 0. And x is 1/3. Don't ask me why, you know the rules. Boom, bada bing, bada boom, bada boom. All right, so that's the end of this. You're on your own with the other two. I mean, I've done so many equations that right now you should be professionals at solving linear equations. And thank you all for your attention. And I'll see you on the next episode of how do we pass our common core algebra state regions, okay, or course or class, whatever. I caught you.